Hi everybody, I am Hürriyetoğlu, one of the organizers of the case workshop. Thank you very much for your time, for your contributions. The workshop will start with keynotes of Elizabeth Boschee and Kristine. The keynotes will be followed by our regular papers, and this will be for today. And we will continue by invited speakers tomorrow. And then the second part will be on the shared task, actually with 3 tasks and a couple of subtasks. So the meeting is recorded. For the questions, I think we should just follow an open conversational mode. Mostly we left some time, hopefully to have it around 5 minutes, sometimes even more, to have just an open conversation. And this was the reason we wanted to have it a live event. So with minimal recordings, it was optional. So you may want to find the recordings on the platform as well for some of the papers. So we are starting with Elizabeth Boschee. She is the director of the Boston office of the University of Southern California's Information Sciences Institute and a senior supervising computer scientist in the Emerging Activities Division. Her current efforts focus on crosslingual information extraction, retrieval and summarization, specifically targeting low or zero resource settings, crosslingual settings with less than 1 million words of bytext or event extraction from non-English languages with only English training data. Prior to joining ISI, Ms. Boschee spent 17 years at BBN Technologies, and there she was director of the very well-known the ICEEVS event data. And we are quite excited to hear her experiences and suggestions and her results. So thank you very much, Liz, and welcome. The floor is yours.
Thank you very much. Let me get this shared here. All right, let's see. Are you seeing my notes screen?
Yes.
Swap displays again. Now, is it right?
Yeah. No,
all right.
Correct.
Fantastic. So thank you very much for the kind introduction. So I am Liz Boschee. I'm with the University of Southern California's Information Sciences Institute. I'm very excited to be here and to be a part of this workshop, thinking about the breadth of events, the depth of events, and how we can actually use those events, how we can use them to understand the world around us, and how we can use them to potentially change the world around us. I'm going to be speaking from kind of a more narrow natural language processing perspective. And what I'm excited to be here is to hear more about how people are actually using the kinds of events that people like me try to extract. Before I go any further, I wanted to acknowledge 2 of my colleagues who aren't here, Shantanu Agarwal and Stephen Fink, who are instrumental in some of the things that I'll be chatting about today. The title of my talk is Events on a Global Scale. So you can think of a lot of things when you talk about global events. For me, from the NLP community, I think about language, obviously. And so I think about events that are being talked about, discussed, reported in languages that we don't understand, or that I don't understand, or that a person building a system to try and find those events and encode those events doesn't understand. Now, that might not just be any non-English language, right? There are other languages with event resources, but there are certainly not event resources in all of the languages of the world and in all of the communities that we care about. So the question is, how can we still get the same level of understanding of events that we're trying to get at in better supported languages in all of the languages of the world? So before I talk about that, I wanted to talk a little bit about, or at least scope what I'm going to talk about a little bit. So there's lots of different ways of talking about events. I think we're all familiar with this, right? There are curated event databases, which require a lot of hard and really interesting work to try and track in the events that are going on in the world. And here you might have, each entry in the database is a single real world event, which might be supported by evidence from a whole variety of sources, written and otherwise. And then you have the events that are actually coded from text. And I've just thrown up here just a handful of the ways to do this and a handful of the ontologies that over the years people have used, and the tools and the programs. There's a much wider variety out there. But I think the important thing here is that a lot of this work has been driven fundamentally by, maybe political scientists is too narrow a word, but people who want to use and understand events in order to understand the world around them, whether that's to, predict whether or not there's going to be a coup, or to, understand the balance of power in the Middle East, or anything that we're trying to understand. And these events have been used in a variety of ways over the years. And then there are also events that I just distinguish a little bit, which still coding from text, but driven by linguists, right? So if you look back, for instance, to the ACE program, so I was a part of the initial development of the ACE event ontology. It was over 15 years ago now. But this was linguists and people in the NLP community coming up with these events and these event types. And it's not that they weren't driven by utility. We wanted there to be events that were useful, but fundamentally we were thinking about the questions involved in the language, and that it makes it a slightly different flavor, right? So the ACE ontology, for instance, was, from the very beginning accompanied by very linguistically oriented guidelines for how you actually annotate things, which is not necessarily the case in other cases, right? It may or may not be important. But one of the great things about an ontology like ACE is that it does come with annotated supervised training data. Now you can view that as a limitation as well if you try to pursue approaches that require this. But it's one of the things that I've looked at over the course of my career, and that's part of what I'm going to be focusing on today. In conjunction with all the different types of events that we have, right, there are also lots of different approaches to event coding. And again, I think we're all familiar with this, but just to try and scope what I'm going to be talking about, right over here, you have actual manual coding of events, which, I used to refer to as, you get a bunch of graduate students, you lock them in a room with like an unending supply of coffee and ask them to read news articles, right? That's not scalable. And so in order to make it scalable, there's also, you can create handcrafted rules, which can be really powerful to be able to extract events from a much broader variety of data. But you still need intelligent, trained people to build those rules. And in the same way, you need intelligent, trained people to build supervised data to be able to build trained models to extract events. And supervised data is great, but it's expensive to create. And there's traditionally been a lot of problems with ontology shift, with domain shift, with language shift. And so there's some real limitations in pursuing approaches that are driven only by supervised data. Of course, there are also hybrid approaches. There's a whole variety of these. So BBN Accent, which was mentioned before, which is a project that I worked on when I was at BBN, was a hybrid approach. So it was a stack of trained models, and then there was a pattern proposal system that used the outputs of those trained models, but then those patterns were curated by humans on top of that. And then there's unsupervised approaches, all sorts of things. I can't possibly address all of these, even on a global scale. And so I'm looking today at primarily systems that are trained with supervised data. And I've already said that there are limitations to that. And so the question is, how can we overcome those limitations? How can we still take this paradigm where we have some training data and we want a machine to figure out how to code events from that training data for us? How can we do that without locking ourselves into a paradigm where we have to pay people, maybe not graduate students, but lock some other people in the room and make them annotate data? So before I do that, I want to talk about, before I get into the kind of global aspects of it, I want to talk about one new angle on event coding, which some or all of you may be familiar with to some extent. But I wanted to highlight it as part of what I think is critical to exploring events in languages with lower resource support. So there's lots of exciting approaches to supervised event coding these days. The neural revolution, or whatever you want to call it, obviously in the last 5 or 10 years has changed everything in terms of these trained models. But one of the angles that has come up just in the last couple of years when looking at event coding, or at least has come up afresh, a current source of inspiration is question answering, right? And so question answering fundamentally is extremely open domain. You just have a question of some sort in natural language. So who sponsored the Federal Firefighter Fairness Act? And then you have some sort of passage where you're trying to find the answers. So here the correct answers are Tom Carper and Susan Collins. I mean, you can imagine how this can be easily applied to event coding, right? Here you could even imagine that legislation, a legislative act is a type of event, and you're trying to find the source or the agent of that event, and you're framing that as a question, right? So why do we care about this for event coding? Why is this angle particularly, in my mind, promising and exciting? So one of the reasons is that there's been substantial improvements in the QA field recently. So if you look at this graphic, which is from a paper that I've cited here, you can see that back in 2018, we were down in the 70s on these tasks, and just over the last few years, it's shot up, and now we can perform above 90 in this particular metric. And there's two primary reasons for this. I think people would generally say the first is just that the deep learning architectures have really, I was going to say transformed the world, but that's kind of a bad pun, right? The pre-trained transformer models have really provided some power that we haven't previously seen. And the other reason is that people have really figured out how to create and leverage these large scale data sets. So it can be cost effective. So you don't have to pay for trained graduate students who understand the nuances of political science or linguistics to create your data. You can just say, hey, random person that I'm going to pay a small amount of money to, here's a passage. Can you come up with some questions and highlight some answers? Right, so that's really powerful. So that's reason number one. Reason number two is that question answering is really open domain, right? So the data sets and the architectures typically don't have ontologies. Now, it's not that people haven't done question answering, especially factoid question answering using ontologies where, first you try and classify the question as to being, am I looking for an animal, vegetable, or mineral, kind of that equivalent. That's not really how a lot of these open domain systems work. They don't have an ontology. You're just looking for a span of text as your answer. And what that's really great for is transfer learning, right, which is really important when we're talking about not being restricted to having to annotate a whole bunch of data for our particular ontology and our particular domain. So let's say that you have some annotated ACE data, right? And you're trying to detect events in the BERT ontology. So BERT, I suspect most people here aren't familiar with. BERT is a current program being run out of IARPA, the Intelligence Advanced Research Projects activity. And it focuses on cross-lingual event extraction. And they decided, let's come up with our own ontology because we all need a new ontology. Why use one that already exists? So it was originally meant to be, I think, very loosely inspired by Cameo, but it has drifted pretty far from that. Anyway, it's a whole different ontology. But there's overlap, right? They both have, right? So BERT has violence and ACE has conflict out attack, and you'd really like to be able to leverage that in some way. But the problem is that you can do multitask learning, and you can have a model where you share maybe you share the transformer stack and you tune it on both tasks. But the parameters in whatever classification layer you have on top, and being kind of hand wavy because there's a lot of different possible architectures, you usually have to throw them away because the event types are just different. And if you're taking a classification based approach where your goal is to say, is this thing a conflict.attack event, then it's just not immediately obvious how to share those parameters with an ontology that's completely different. On the other hand, if you have a data set like Squad 2, for instance, this is the Stanford question something data set. I can never remember the exact acronym, right? But it's 100,000 question answer pairs. So there's potentially a lot of power there. And all you're trying to do there is in a passage, find the start and end of something, right? And so that kind of architecture makes it much easier because if you can frame the better questions in a way where you're looking for a start and an end, then you can theoretically share all of those parameters, which really helps with transfer learning. And I'll show some proof of that later. Finally, why question answering? Why is this potentially helpful as we think about language shift and domain shift? One of the reasons why we think that question answering works in the current architectures that we use, and why these current architectures, not just for question answering, but also, for instance, this graphic is about RTE, or recognizing textual entailment, is that they all have this concept where you have a passage of text that you're looking at, but you also have a prompt or a question or something which tells the model what your current task is, not just broadly like I'm looking for events, but I am looking for arguments to this specific trigger or this specific type of event. And if you can empower your whole model with that kind of task-specific guidance, it seems to really help. So this is a paper published, I think this spring on arXiv by Debanjana and Sasha Rush, trying to classify or trying to quantify how many data points is a prompt worth. And so if you see here, they have this lovely graph. Again, this is for the RTE task, but I think you can learn something similar. So they have a run without a prompt, that's the purple line, and a run with a prompt, which is the orange line. And you can see that particularly in these lower resource scenarios where you have only, say, 1,000 training points, you get a significant boost in performance from including a prompt. And these are the kinds of scenarios that we're talking about. The BERT program that I mentioned, its goal is to do cross-lingual event extraction, but its goal is also to do so with as little training data as possible, even in English. Trying to mimic the real world scenario where, if someone says to you, I'd really like to detect, I don't know, smuggling events, and I don't have any current patterns or training data for smuggling events. How can I do that? If you tell them, oh, sure, go annotate 600 Newswire documents for me, it's just not going to happen, right? Okay, so those are some of the answers to the why question answering. Why do I care about this? So does this actually work for events? The answer is yes. So this is a very simple example. This was the first thing we tried when we were starting to explore this. It's just a proof of concept to say, well, what do we really care about with events? We care about times and locations, the when and the where. So can you just form that as a question? When did attack happen? Right? It doesn't have to even be grammatically sensible. If you look at some of these crowdsourced data sets and you actually look at the questions, some of the grammar is terrible, right? Some of that is clearly written by people who are not native speakers of English, but that's fine, right? When you get enough data, that kind of noise is perfectly fine. And it also enables us to use slightly ungrammatical prompts for our model without the model complaining too much. And we frame the task like this. We just say, all right, this is a very classic QA architecture. This is pretty vanilla. We're just going to feed this whole thing to a transformer model, right? So you've got the question and then some separator, and then you've got a context, and then the goal of the model. I can't honestly even remember exactly which one we tried here, but I think we just had a very simple classification layer on top of the transformer stack that was trying to predict for each token whether it was the start or end of the answer. Right? And we took this two-stage approach, which is very classic for transfer learning. We pre-trained on this big data set, this Squad 2 data set, which is open domain. And it has some when and where questions in it, but that's not the majority of the 100,000 questions in it. And then we fine-tuned it on questions that we created from the ACE data set, right? So the ACE data set has sentences like this that have time and location arguments annotated. And what was really cool was that we did see a significant boost over our baseline sequence labeling architecture. And so the sequence labeling architecture was one we had been playing with for a while. It's pretty standard. There's nothing terribly, nothing terribly deficient about it. But this QA-inspired approach is really able to excel in this context. Largely, we think because it was able to take advantage of that Squad 2 data, which the sequence labeling data was not. So we thought, okay, can we use a QA approach for everything, right? So not just when and where. So again, some of these examples are drawn from the BERT program. They use agent and patient. Other people use source and target. There's all sorts of things you can use. There's also much finer grained event slots like, who was wounded in this event. And so the question is, could we change all of that into questions? So here we have ISIS claimed it downed Russian passenger flight 9268. All 224 people aboard died. And you see, you can just change these potentially into questions. Who claimed responsibility? How many were killed? Which organization is the perpetrator? What was the physical target? These can be very template-like, and we can use them to find these answers. Now, if you've read the T5 paper, this graphic will be familiar, right? So one of the things to have in the back of your head is thinking about, okay, this question answering stuff is really interesting. I think it does actually intuitively, maybe not always mathematically, but intuitively, it has something to do with generative approaches as well. Thinking about how you can ask a question and then have it generate the answer or find the answer, but they're still both prompted in some way. And I'll talk a little bit more about that later. So yes, the answer was this works. So we applied this to, again, the BERT basic events problem. Basic events, think of that as basically, it's very similar to ACE. So it's kind of a similar sized ontology. It's about 50 event types and similar set of arguments, mostly agents and patients, things like that. And the initial results showed some promise. And I wanted to highlight one particular result, which again, harping on the sense of transfer learning, right? So if you see this blue line here, this was our model trained with just the basic event data. So there's about 1,000 sentences in the training set. So this is smaller than ACE. 1,000 sentences in the training set. And if you have 1,000 using this particular model that we were using, our performance started to plateau around 70, I think. But if you only had, so 5% would be what, 50? If you only had 50 sentences, then your performance was pretty dismal, honestly. I don't think an F1 of 30 is, it's hard to view that as usable in English. But the great thing was that if you use this orange line, right, where you pre-train first in the squad 2 data, then even only using 50 sentences from the better data with this specific ontology and all the specific domain sensitive things, you can actually get your performance to start all the way up at 60, right? And I might not be able to persuade someone who wants to annotate smuggling events that they want to go annotate, 600 documents, which is, whatever, 1,200 sentences or 12,000 sentences or whatever. I might not be able to persuade them that they want to annotate a whole bunch of documents, but I might be able to say, here's 3 Newswire documents. Can you please go annotate those for me and get 50 sentences and train a model. And so we think this actually gives some promise for thinking about domain shift. One problem remains, though, which is that the standard QA architecture, which I described, is not immediately suitable for cross-lingual purposes, right? Because those natural language queries are in English, right? And so if you're using an English language model, it's not going to be suitable to just snap your fingers and move into Arabic. So we modified our approach somewhat. So we have a name for the system. It's called IU prime. It's because the idea is to prime the language model with what you're looking for. And the idea was to just take inspiration from question answering, but make a system that's language agnostic. Okay, and this is an argument attachment system, and it does provide new state-of-the-art results on ACE argument attachment, or at least they were new state-of-the-art results before this conference. I haven't reviewed everything from this week. So what is the intuition here, right? So again, let's just assume, this is not a deep dive technical talk, so I'm waving my hands a little bit about some of the details, but let's just assume we have a transformer stack and we're going to send some sentence through that stack. And we're going to get a vector at each token. And then we're going to put something on top of those vectors that turns them into arguments, right? So some sort of classification layer. In our case, we have a Bijl STM and a classification layer. All right, so these are the vectors. These gray boxes are the vectors that we get out of the transformer for each token. And they're based on this whole context of the Taliban abducted young people. But say now we know that we're caring specifically about the arguments for abducted, right? So what we actually do is include abducted in what the information that's actually being sent into the transformer. And what this does is actually change all of the vectors that are produced, right? So the existence of this part over here, right, it's part of the context. So it's going to change the representations generated by the transformer over here. So the representation for officials is this red vector, where before it was this the gray vector. And if we change abducted to believe, now we have a purple vector. So now the representation for officials is different based on whether we're trying to figure out the arguments to abducted or the arguments to believe. And we think this is one of the keys to making things work. And one of the ways we did it this way is that this is in fact language agnostic, right? Because the only, if you were doing this in Arabic, you just have an Arabic sentence and then you'd pick your Arabic trigger and put it here, and everything would be hopefully just fine. Okay, so this is the full architecture. Again, I'm not going to dive into this, and we have a lot of variations on this. So in this case, we're actually priming by both the anchor as well as the name of the role. In this case, what we're doing is pretty classic. This part's a little bit vanilla, right? So we're just stacking up the anchor or the embedding for an anchor, an embedding that we train up for event types, and then an embedding potentially for this token. I mentioned we have a Bijl STM and then a linear classifier. In this case, we're trying to classify at each token whether or not the thing is an argument. We also have a version that does the IO span labeling. I think those details aren't particularly important. The sense here is though that I wanted to present a particular system in which we could explore different ways to do cross-lingual event extraction, which is where I'm headed. But this is the system we're using. This is an argument attachment system. We use a pipeline system here because we've been focusing on argument attachment. So our trigger system, very simple, definitely vanilla. It's just a single classification layer on top of a transformer. I would describe that system as fine. It's not amazing. It's about 3 points behind the state of the art. In order to get to the state of the art, you really have to have a system that jointly predicts triggers and arguments. That's what the state of the art does. But for our purposes, it's close enough. I think we're not that far off. And this is not super important. This is just to situate that IE prime system in the state of the art, comparing it. So one IE was, as I said, at least until recently, I have no idea if that's still true, the state of the art for monolingual event extraction on ACE. And it uses a joint neural framework, as I mentioned, to extract globally optimal IE results, right? And so it actually does events and relations and entity tagging, a whole bunch of stuff all at once. It's a pretty cool system. I included Do and Cardi as well, which is also an approach to question answering. I mean, an approach to event extraction motivated by question answering that came out in 2020 is one of the things we looked at when we were developing our system. But you can see that our system does actually provide state-of-the-art performance on argument attachment and is, you know, like I said, kind of reasonably within range on the system triggers, at least close enough to in range for it to be a valid test bed for us to start thinking about cross-lingual things. So let's talk about cross-lingual things. So tracking world events requires dealing with sources in many languages. It just does. We don't have, you can't just read the New York Times and hope to understand what's going on in Kazakhstan, right? Until relatively recently, there have been two primary options for this. Some people call them translate train and translate test. Some people use other names for them. Internally, we started calling them path A and path B. That's meaningless to anyone else, but there were kind of two main options. One is to somehow get training data in your target language. So if you want to extract events in Uzbek, you need to get Uzbek training data, right? We'll talk about how you can do that, and then you build a model there. Now, of course, this idea of getting training data only works if you have a trained system, right? If you're generating rules, then this path is you're kind of out of luck unless you have, someone from the foreign country or the foreign language community that can build rules for you. But that can be kind of challenging to find, obviously. Then the other option is translate test, right? So take your data, take your test data, translate it into English, and extract your events there, and then you're done. You just need your English model, right? You can just use machine translation to solve all of your problems. But recently, right, there's a third option, right? So to use a powerful cross-lingual language model and somehow magically train in English and then extract in your target language. Okay. So I'm going to try the purpose of the rest of the talk is really to just some case studies and some exploration of what the strengths and weaknesses are of some of these approaches as we think about how to pursue global event extraction. Right, and this is by necessity going to be narrow in various ways. It's meant to be a flavoring of possibilities. Right. So option one is to annotate training data in your target language. And so obviously the best way to do this, to get the best data, is to have a human do it. That's why I love ACE so much, is that they paid people to do this in Arabic and Chinese 15 years ago, which is great. Now we have that data, but it's one ontology, it's fixed in time, it's expensive, it's inefficient, it's not scalable, right? So what can you do? Well, if you've got English training data, let's just assume you do, you can translate that English data into your target language, right? You can project it. So this relies on machine translation. It also relies on your ability not just to do sentence-to-sentence machine translation, but to do span-to-span machine translation to actually align all of your annotations. So this is noisy. It is better than it was, right? So if you tried to do this 15 years ago, it was a lot harder. But machine translation is better now. Alignment is better now because you can do it using language models, but it's still noisy. Okay, so that's option one. Option number two is, just leave it all to machine translation. And sometimes I wish we could do this, but MT is at least not yet the silver bullet that we're looking for. So this is, pretty sure this is Farsi. I don't speak Farsi, and I made this slide about a month ago, but I'm pretty sure this is Farsi because it's what we were working on. And I just ran it through Google Translate. And honestly, I would be dubious of any events that are extracted from this English passage. I'm pretty sure there's something about violence. And it says maybe rockets from Pakistan. So maybe Pakistan is the source of the rockets, but it also calls Pakistan friendly. So maybe there's something lost in translation, and maybe the jihadists are doing something. But honestly, I'm not really sure, and I would not trust a model to be sure either. Right. So option two is an option. but it may or may not solve all our problems. So Farsi is hard, admittedly, right? So there are easier languages. So this is a case study. This is a little old now. This was back when I was at BBN. And we were looking at how well our system performed over machine translation. And we wanted to quantify this to some extent. And so, so we took this data set that had parallel data in English, French, and Spanish. Those are some of the languages of interest to the program we are working on. Unfortunately, the Statistical MT workshop has a bunch of parallel data. This is all news documents, which is what we are looking at. So BBN Accent, as I mentioned before, it's a system designed to code cameo events. So there's 20 types of events and a bunch of subtypes. And each event has to have a source and a target in the same sentence. And as I mentioned, it's a hybrid system where there's a bunch of trained models, and then there's patterns that are the patterns make use of the elements detected by the trained models, and the patterns were kind of semi-supervised, proposed, and then curated by humans. But one thing to note about it is that most of that stuff isn't very important, but that it is very syntax dependent. So you should take these results with a grain of salt. Syntax is notoriously difficult to translate. And so that may fall in, that may actually affect these results. But still, they're results worth looking at. And all we did was we just translated the French and Spanish documents into English. So now we have 3 versions of each document: an English document, a MT from French, and an MT from Spanish document. We run them all through the coder and produce events. And then we have a human judge those events. And honestly, it could have even been me. I don't know. I don't remember who we had do this. One of our people annotated these events. We randomly shuffled them and said, basically just judge them, right? We don't have a gold standard. We did not have someone go through and annotate all 606 news documents for all, it's like 211 or 199 cameo types. But we just had them judge the system output so we could compare things. So you can't judge recall, but you can judge relative recall. I think, the thing that's interesting about this study is that you can see that the precision numbers actually don't degrade that much, right? So the MT isn't great. You can tell it's MT when you read it, but the precision isn't that bad. So when the system finds something, it's close to as correct as if you had found it in the original native English. There's degradation about 15% relative, right? So it's degraded, but it's not devastated, right? But what's devastated is the recall, right? So the number of correct events that the system is able to find. And so at least for this particular system, using option 2, the translate test approach, it's not as likely to hallucinate things that aren't there. But if any part of the necessary signal is dropped by the MT, then the system just throws up its hands and says, yeah, I don't know. I can only find a target here. I can't find a source. I'm just not finding, I'm done. I'm not finding anything here at all. Right. And again, some of this is particular to this particular system, but it's something I've observed in other settings as well, that things getting lost in MT is more of a problem than things getting hallucinated. Now, to be fair, neural models are better at hallucinating things. So it might depend on the MT model that you're using. Okay, so that's kind of one case study on option 2. Let's talk about option 3. So we start in option 3, we start with a powerful cross-lingual language model, one that is designed to capture multilingual semantic content. So our particular favorite is XLM Roberta at the moment. That's what we've mostly been using. Seems to perform significantly better for these types of tasks than, for instance, BERT. You take a model like this, whatever your favorite is, and you build a model using just your English training data. And then you apply it to a foreign language, some foreign language that's represented in that language model. Doesn't matter. Doesn't matter. You don't have to tell it ahead of time which one you're training it for. And then I went back and forth with what word to put here. Power, magic, presto, right? Theoretically, it just works, right? That's the glory of option 3. Now, one little note, right? So the baseline strategy I just described is that you start with this pre-trained transformer model and you fine tune all of the weights on some special purpose English event training. But then there's this step where you have to hold your breath and cross your fingers and hope that you haven't fine tuned away all of the cross-lingual knowledge from that model, right? Because there's nothing in your fine tuning process that in any way encourages it to keep those representations for English words anywhere close to the representations for Arabic words or Farsi words or anything like that. So you have to kind of pray, and prayer is not a good basis for algorithms. So a better strategy might be to maybe freeze some of the layers of the original model to try and say, yeah, you can move, but you can't move too far. So I'll just share one of the experiments we did here that confirmed that this was in fact a reasonable strategy. So this was it's a different ontology. This is the better abstract events, which they essentially don't have whatever. They're kind of quad class events. They're a little strange. Not important. But what you see here is that, so this is the English to Arabic 0-shot setting. And what you see here, and this is what we froze. So this baseline line up here is what would happen if you didn't freeze anything. And in fact, it doesn't perform as well as if you freeze. If you freeze too much, performance goes down. You've got to actually let your model train on your actual task. But if you freeze the kind of the bottom part of what you have, you can actually prevent the model from drifting too far. And it does better when you then apply it to a new language. And then the intuition here is confirmed because when you look at just the monolingual context, where it's just English to English, you don't want to freeze anything, right? If there's no reason to freeze anything, you don't want to freeze anything. Let the model learn, let it do its thing. The whole point is that these things are smarter than we are. Let it learn. And in fact, just letting everything tune is your best bet if you're just dealing with a monolingual setting. But if you have reason to believe that you don't want it to move too far, then freezing a little bit helps. Okay, so I said I would compare options 1, 2, and 3. So I'm going to do that. I am going to use ACE to do that. ACE is, people are very broadly familiar with it, but for those who haven't looked at it in a while, it's a pretty general ontology. It's widely used. As I mentioned, it has manually annotated data sets in English, Arabic, and Chinese. It also gloriously now has open source pre-processing provided by David Wadden and the folks who did Day1, who have my eternal gratitude because ACE is notoriously a pain in the neck to deal with. If you look at that code, it has things like, if I'm in this document in this sentence, then I have to adjust this offset to be this thing because it's broken. It's just a nightmare. Okay, so with that data, what can you do? So we start with the native English training data. And so option 1, right, was to create your own Arabic data. We're going to be looking at Arabic here. Okay, so we project it. We have a method to do this. It uses machine translation and then language models and translation tables to align it. Once you have that, you can build a model and you can apply it to Arabic. All right, now you're done. That was your option 1. And then you can also do option 2, which was, okay, fine, build a model in English and then apply it to English MT. Once you've had this model, however, if you built it using a multilingual language model as its base, you can also apply that same model directly to Arabic. That's option 3. Okay. And then there's a hybrid option where you say, well, I've got this projected Arabic data and I've got this English data. Why not both? Right, so apply them both, but because you're using a multilingual language model, you can still apply it directly to Arabic. Okay, those are our options. So I'll cut right to the chase, at least in this context. The best option is the hybrid option, right? So there's a few things going on here that are interesting. The first is that actually, at least in this case study, all of these are actually pretty close, which is pretty interesting, right? So they seem to be drawing on the same strengths and weaknesses to some extent. Right, and so the one outlier you'll see is trigger performance in the pure 0-shot case, but the projected annotation scenario is pretty good. It's not quite as good if you do the translate test approach, but this is probably within the noise. Now I'm hovering on these argument numbers, right? The argument numbers depend on the trigger numbers. So in some sense, this is the combination number of triggers and arguments because you can only find arguments for triggers that you found. But the best approach is by actually having a hybrid system, which kind of makes sense, right? It allows us to take advantage of 2 types of data. You've got the English data, which is not noisy, but it's in the wrong language. And then you have the projected data, which is in the right language, but it's noisy, right? Because it was projected through a noisy process, right? And so they each have their own weakness, and maybe the model is able to kind of take the strengths from both and improve a little bit across the board. And I included this monolingual Arabic number here to say as well that the point here is not that we have solved the problem. We are not now doing as well as we could be doing if we had if we had an actual Arabic annotator who could annotate the data for us. You will see some papers that do try to claim that. I will say, in my opinion, some of those papers have really biased their data set in a way to make that obvious. So for instance, there's one way of testing things which reduces the problem to one where it has a kind of an equally balanced data set of positive and negative examples for argument attachment. When the real ratio is dramatically skewed, most things in a sentence are not arguments to a particular event. And so if you skew your data set enough, you can try and make it look like you're doing as well as having native data, but I just don't think we're actually, when you score the whole end-to-end task, I don't think we're there yet. Dig a little bit into this trigger number here. So this is recall precision F for trigger detection. And again, this is the really interesting number, which is that we see in the zero-shot context, for some reason, it just can't get its recall up, right? Or at least that's where its optimal operating point is, right? So it does have higher precision than the other approaches, but for some reason, when it's only seeing that English data and the only way it has to find the Arabic words is going through this language model and doesn't have access to any Arabic data, projected or otherwise, and it doesn't have any access to machine translations power, for some reason, it's just not very good at finding those triggers. So that was an interesting result. And so I think actually trying to improve the zero-shot approach to be able to overcome that recall gap is one of the things that we're working on. These are the same recall and precision and F numbers broken down for argument attachment. So we ran these using gold triggers. So we didn't try to include option 2 where you translate to English because there weren't gold triggers in English. It didn't make sense. But what's interesting here is that the pure zero-shot approach actually is better, right? So there's something about including the noisy projected data, which isn't able to help enough. So there's something about, at least for this task, that if you use just the English data and just the language model itself is powerful enough to carry you past these other approaches. So that was kind of interesting. What about another language though? Right, so we were just showing you Arabic results. So and that's because what we were working on. Here's some initial work in Farsi. So this is again this is for the BERT program, which is not at least not currently a public ontology, or although I hope they will release the data. And so these are the numbers you've already seen. This is just triggers. These were the numbers for the Arabic ACE numbers. And again, we said the hybrid approach was best. And when we run for Arabic and for BERT, this is a much easier ontology. In fact, it doesn't, I think these might be the numbers actually where they don't care about event type at all. They've removed event types in the most recent iteration of there's 2 ontologies, but this was the one where they removed the event types. That's why the overall numbers are higher, but you can see the pattern is similar, right? So the pure zero-shot is lower, and the option 2 where you translate using MT is a little bit lower than this hybrid approach. So it's interesting. It's at least consistent for a very different task and domain. You know, the data is 20 years later. But we see the same kind of pattern within Arabic. We see a very different pattern in Farsi, right? And so here, the pure zero-shot approach, even for triggers, is much better, right? And we don't yet know why quite this is, right? This is all very interesting and all. There's a lot of stuff to be kind of waded through, and sometimes it's a little hard to understand what these complex language models are doing. One of the things to note is that, you know, if you look at this number 78.7 and 77.1, the Farsi just starts off a lot higher in a zero-shot context. It's able to do a lot of the job just relying on English. And so when you add, maybe when you add the projected Farsi data, it's noisy enough that the model is basically saying, I'm already pretty good at what I'm doing. Adding any noisy data isn't going to make me better. In fact, it's going to make my performance go down, right, to 73 or 71. And here, the translate test approach is actually noticeably worse, right? And so this could be because Farsi MT is just worse, right? So at least the models we were using, right? I mean, I suspect Google has access to more training data than we do, but in terms of the publicly available Farsi data and Arabic data we could get, and we've worked on Farsi quite a bit as part of a different program for low resource MT. But even so, there's a gap in the Farsi and Arabic blue performance. And so maybe the fact that MT is worse for Farsi means that zero-shot kind of can pull ahead, right? Because zero-shot is the one that doesn't rely on machine translation. It's also possible that the language model is stronger for Farsi. So if you look at the graph of languages that are included in XLM Roberta, I think Farsi is like the 5th most common, which you might not expect, but it's more common than Arabic. And so maybe that language model simply has a better set of representations for Farsi. Something else might be going on. And so we're looking into that right now because Farsi is the language for the phase 2 of the BERT program. While we're talking about language models, I just wanted to close with one little aside, which is this fact that language models keep getting bigger and they keep getting better. And language model strength is really central to our approach, particularly for zero-shot cross-lingual transfer. So one of the things we did when we were generating these numbers is we wanted to assess, well, how much of this gain is actually just due to the language model getting better. And so we took, so XLM Roberta, they've released both a base model and a large model, right? So let's just run the same systems with a base model and a large model. And what do you get? So this is all of these options the blue is the base system and the red is the large model. And what you can see is that, as expected, I think, the option that benefits the most from a better language model is this pure zero shot, because it's so dependent on the language model. That's all it's got going for it, right? And so that also means that potentially, as these models continue to get stronger and stronger, the zero shot approach is going to continue to sail ahead. And I think you see the same thing in these argument charts. It's not quite as vivid, but the zero shot approach for arguments does gain the most from the new language model. In fact, that's what enables it to kind of push ahead and actually be the best for arguments. Okay, so this is just a snapshot from this summer or from this spring of things that we're doing in the space of cross-lingual event extraction, some things that are going on in the space in general, thinking about question answering and event coding. I think one of the things that I'd like you to take away is that this pure zero shot approach is now almost better than any other alternative. It's probably only going to get better. And the thing that's key about this, why do I care? Why not just use why not hope for these other approaches to get better? Is that it doesn't require any parallel data at all. So all of the other paths, option 1, option 2, and the hybrid path, they all require machine translation in some form or another, whether to translate your test data or to translate your training data. And the zero shot approach doesn't require any parallel data. You can train these language models without bitext. They just need lots of monolingual data, which we can get in this day and age of the internet. We can get monolingual data in Farsi. You can do a web crawl. We've done it for all the languages we're doing for low resource MT, but you don't need any bitext. And I think that makes it incredibly flexible. Also, as we think about domain shift, right? So maybe you can get good bitext, which can be like a reasonable MT model, but if you start talking about a really technical domain or something like that, maybe you can get a bunch of monolingual data and fine tune your language model, but you're not going to have bitext in your technical domain for, whatever, technical police domain you're dealing with in the Philippines. And so I think that being able to rely instead on these models that don't require bitext is an actual significant advantage. Another thing to note is just that I would say that these models based on more of a question answering approach rather than a classification based approach do allow flexibility and transfer learning to support new ontologies, also new domains, also new languages, as I mentioned. And I think there's a lot to be gained by exploring these kinds of approaches. And then, as I briefly mentioned earlier, I think that alongside of this, generative approaches seem to show some real potential here. And so at least in my mind, there is an intuitive inspiration that is shared across these approaches. Again, they're very different kinds of models in some ways, but in some other ways, they're somewhat similar. You can imagine asking a question and then having the model asking a question, reading a passage, and then having the model generate an answer as opposed to find the answer, right? But this idea is similar, that you're giving it both the task and the place where it's supposed to be, the context for its understanding, and then you're asking it to do something. So there's a paper, NACL 2021, that did this. My colleague, Violet Pang at UCLA, who's working with us in the BERT program, has also been exploring generative approaches to event extraction, which is, I think there's some really exciting things to be seen there as well. And that wraps up my talk. That's, again, it's meant to be a flavoring of what people are doing in cross-lingual event extraction, but I think there's a lot of exciting things going on, and I think we've moved into a space where we really can think about understanding global events in their native languages in a way that we were not as easily or as effectively able to do in years past. So thank you.
Thank you very much, Liz. It was quite inspiring and really cutting edge. We have maybe 10 minutes for questions, and please raise hands. Osman, Mutlu.
Hi. Thank you for the great talk, and there are some really great insights that I can see here, especially I'm interested in the QA related stuff, like maybe we can really use the question answering for like totally replacing event extraction, maybe. I don't know, that's really exciting. I would like to add an option 4 to your 3 options for cross-lingual modeling, and that's like there are recent papers on cross-lingual unsupervised domain adaptation. and using the target language's raw text, you can adapt your model. You can adapt your original model, whichever downstream task that is. Like it can be event extraction. I don't think there is any paper on it yet in exactly event extraction, but you can like adapt your model using target language's raw text, and it performs better than zero shot and translating and other stuff, the other options that you.
If you have any links, please put them in the chat. I'd be interested.
Okay, I will find them after I ask my questions. So the my first question is how many. So you prepared questions for each argument of events, and of course for trigger as well. Do you have a data size for that you can show, especially when you compare the state of the art, the one IE, when you compare your model,
so
IE prime?
The questions that we created for training are just created from the same training set that everyone else uses. So it just takes the same data that is used to train a classification-oriented model, and it just transforms it into instances that look like questions, right? So
you used none of the squad?
None of the what?
Squad data or something else?
So
no?
for the for that transfer learning approach that I talked about, where I showed that graph, yes, we used squad. For all of the rest of the results that I was talking about with the cross-lingual stuff, we did not, because squad is English only. So,
I was asking your SOTA model that you passed the.
Yeah, the SOTA numbers don't use squad at all. They just use the ACE data.
Oh, okay, just the ACE data. That's really cool.
Yeah, I mean, I'm going to be totally fair. There's lots of people so my colleague Violet Peng at UCLA using her generative approach. We both have papers under submission right now, which have results which are almost equal, right? And so I think the state of the art is just gets pressed every year, right? That's why I said I haven't reviewed the ACL stuff yet. I think there's a lot of potential in both of those approaches. Yeah.
And in order to form your questions, you need the triggers as well, right? So your arguments are dependent on your triggers.
Yes.
So do you use the goal triggers or your predicted triggers?
So let's see how fast I can get back to the slide with those numbers.
That was very bad.
There were two options, if I remember correctly.
Yeah. So this year, can you still see my slides?
Yes.
Yeah. So these numbers here are on gold triggers. We had to generate. There's an asterisk here. We had to generate them. So they've released one IE who's released their code.
I see. I missed this part, I guess. Okay.
I went through it very fast because I was trying not to have this be a let's talk about our particular SOTA results kind of talk, but more talking about what we use the system for. But I think it's important to contextualize our system in that, this isn't just some crappy system that's not going to perform well, but it's actually a reasonable system. So then for what we see here is that the one IE system outperforms on both triggers and arguments. But really, it seems like we're so close on arguments that what's really going on, obviously, is that when you're 3 points down on triggers and you have a pipeline system, you can't catch up on arguments.
Okay, thank you. Again, thank you for the great talk.
Yeah. Thank you.
Any other questions, comments, feedback? We have Andy Halderman.
Yes, thanks. I really enjoyed the talk and I learned a lot. I had sort of a specific question about at the beginning when you were talking about using QA for doing the where-when extraction. And you had this result that was using squad and also ACE. And I was wondering if you ran it just with squad and then with squad plus the fine-tuning on ACE, and what the difference is what benefit you get from using ACE.
That's a great question, and I probably could answer it with 15 minutes with my Slack inbox or my Slack search, but I probably can't answer it off the top of my head. As I recall, you could get a long way there with squad for when and where, just because when and where are particularly well represented in QA sets, and so I think we gained like an additional 3 or 4 points by fine tuning on ACE, but you could get a long way there with squad.
Okay.
And that's probably why it was such a success over our classification-based approach, was that the ability to include this massive data set, which is actually pretty well tuned for when and where questions, really just, shot it up over. I mean, ACE is a big data set for if you want a gold standard annotation for a large event ontology, but it's not a big data set when you compare it to something like, oh, 100,000 questions over here.
Yeah. Any other question from Andy or anybody else? I have two questions.
Great.
From the input and the output aspects.
Mm-hmm.
So if you ask the model who sponsored something, I spent a week on question answering. So with this week of experience, so what when I ask the model something that that doesn't have the answer in the text, it throws something random. This is one thing. The other thing, we keep talking about, okay, we don't need a lot of stuff, but sooner or later we need to evaluate things. So how much effort will remain, at least for evaluation for us?
Yeah, I mean, and that's why I say I love ACE so much, is that we actually have the ability to evaluate what we're doing. We can try and build a model for Arabic, pretending we have no Arabic data. Oh, but then secretly we can actually evaluate how we're doing. And this BERT program that I mentioned, their shtick is to not give us anything to evaluate on. And it makes all of the scientists crazy because, we spend a year working on something and it's not until we run the final evaluation over at MITRE that we get to find out whether anything has worked. So we keep working on the PM to be like, no, please give us data. And so at least what they did this year was they released all of last year's data to us, which is Arabic. Now we're working on Farsi. So I agree. Actually, I think that actually when we're talking about research, like actually trying to make progress in the field, I would say the force multiplier. I hate that lingo, but I think it really is having some evaluation data. And I think that having gold standard reusable evaluation data, if you can get it, can really drive research progress. But it doesn't have to be as big as a training set, right? And so I think that, it doesn't, and you don't even necessarily need a dev set, again, because you're working under the assumption that you don't have any native language data. But I do think that putting in the effort, if you're in a context where you can afford it, to have someone generate some evaluation data for you is really helpful. And in fact, we would do that for the BERT program because it's not that expensive to get a little bit of data, right? And you can maybe crowdsource it and maybe not be as good, but it's against the rules of the program. We're not allowed to create our own.
Perfect.
But on QA though, in terms of the first thing you said about hallucinating, there is a difference between the different QA sets. So some of them assume that the answer is in the passage and some of them don't. I think Squad 2 is one of the ones where it doesn't assume the answer is in the passage. So it enables you to train a model that can learn that sometimes the answer isn't present, which is what you would need for event extraction, because obviously not all arguments are represented.
I see. It is one of the configurations, maybe.
Yeah, exactly.
Yeah. And maybe as a note, we may just to maybe not rely on real evaluation data, like you said, either crowdsourcing, or we should work on paths to evaluate, like something below score for event studies. I don't know.
Well, and even better, maybe you can have downstream tasks that use your data. There's advantages and disadvantages to that. So I remember in the ArgFuse program, we were able to improve both the recall and the precision, but particularly the precision of the underlying event data. But its effect on the actual, so the ArgFuse program was designed to predict political instability. Its effect on the ability to predict political instability was much less, right? Because those models were already dealing with a whole bunch of noise, and those models were, not to anthropomorphize them, but they were happy to be like, oh, less noise, okay, fine, well, I can still find the signal, it doesn't bother me, right? So having kind of extrinsic versus intrinsic evaluation, I'm always in favor of having both, right? You can't learn everything from intrinsic evaluation, but you also can't learn everything from extrinsic evaluation.
Thank you very much for the comments and for the great talk. I really feel we are at somewhere around the state of the art with this push in technology. And now we will have Kristine Eck from UCDP. Kristine Eck is an associate professor at the Department of Peace and Conflict Research at Uppsala University. where she serves as the director of the Uppsala Rotary Peace Center. Her research interests concerned coercion and resistance, including human rights, police misconduct, state surveillance, and conflict data production. She was director of Uppsala Conflict Data Program, which we know as UCDP dataset, and a visiting researcher at Oxford University, Copenhagen University, the University of Notre Dame, and Kobe University. She will be talking about machine learning in conflict studies, reflections and on ethics. So we put this talk, the second one, just to have an hopefully interesting angle on all these techniques going on. But what are we really doing right things, or how it can be better from a political scientist point of view? So thank you very much. And we are excited to listen to you, Kristine.
Great. Hi, thank you. And thank you to the organizers for the invitation to speak here today. It's really a pleasure to address this crowd. Right, so in this keynote, I want to talk about our ethical obligations as scholars, and in particular, the ethical imperative to get it right. And getting it right relates not only to model precision and sort of technical methodological issues, but also to the quality of the underlying data and to whether the models we generate inadvertently reproduce or obscure political biases. And I think most scholars tend to be hyper aware of modeling and methodological issues involved in our work, and less aware about sort of data quality issues. So I don't need to tell you that advances in machine learning are really revolutionary in their potential to analyze massive amounts of data, and in doing so create new knowledge bases. But what I want to talk about is the responsibility of wielding the power to analyze these data, since the public attributes a high degree of confidence to results which are based on big data. So there's two parts to this keynote. First, I want to begin by discussing this ethical imperative to get it right. What does that mean and why is it important? And then I'll suggest some measures that we can take to help ensure that our research does get it right and minimizes the harm that it could possibly do. So as you heard from the introduction, I'm also not working with the same within the same discipline as you guys. I'm not a machine learning or computational linguistics scholar. I'm a social scientist, and I work on civil war and human rights. But I have collaborated on several projects with that involve machine learning tools, and so I am kind of aiming to share some thoughts that have arisen from those collaborations, and to sort of draw attention to the societies that you draw these data from and who you're ultimately reporting your results to. So to set the stage, let me start with a story about what can happen when you get it wrong. So many years ago, when I started my graduate studies, I kept running into a claim about armed conflict. And there were two versions of this claim. The short and the simple version said 90% of fatalities in wars today are civilians. And the longer and more complex version said, in World War I, only 5% of the victims were civilians. That number rose to 50% in World War II. And by the 1990s, 90% of war deaths were civilians. So this claim, you in one or the other version, you could find it really, everywhere. I found it in the European Union security strategy. I found it in United Nations Security General reports, countless NGO reports, academic articles, news media. And prior to starting my graduate studies, I had spent a couple years working as an annotator for the Uppsala Conflict Data Project, right, the UCDP. And so by the time I came across this claim, I had read tens of thousands of news articles about armed conflict. And for each one, I'd carefully recorded, who had killed whom, where, when, what was the context. And so I knew from those articles that determining how many people have been killed in any given event, much less an entire conflict, is really fraught with uncertainty. So if we take a typical example, a government drops a bomb in a village, claims that it hits a rebel headquarters and killed dozens of rebels. Meanwhile, eyewitnesses claim the bomb killed over 100 people and they were all civilians, right? These kinds of conflicting versions are typical of conflict reporting. And adjudicating between the truth claims is extremely difficult. It involves a lot of source criticism and a lot of contextual knowledge about how particular conflict parties behave and what their incentives are to misrepresent the truth. And in many cases, we just have completely insufficient information. We can't even verify whether anyone was killed, much less who they were and under what conditions their deaths occurred. So, knowing this messy state of kind of estimating conflict fatalities and in distinguishing between civilian and combatant, I was immediately suspicious of any estimate that is exact. So my immediate reaction to this 90% civilian estimate was that it was far too precise to possibly be accurate. And so I spent a while chasing back references, trying to find the original source, what data was this based on? And eventually, after a long search, I discovered that the origins of the claim could be traced back to an obscure publication from 1991, which of course already calls into question the claim itself that 90% of the fatalities in the 1990s or today were, that kind of makes it impossible to be correct considering the publication came from 91. It's this guy here. And looking at this source, there were two problems with it. The first was that the claim was based on really poor quality data. It was just bad scholarship. And the second is that the claim itself in the small sort of booklet that this is had gotten mangled on the back of the book. So it had been badly summarized back there. It turns out that this 90% estimate, which is based on bad data in and of itself, but also included not just fatalities, but they were also referring to people affected by conflict, so refugees, IDPs. And then it becomes obviously quite self-evident why you'd have a large number of civilians there. So, unpublished UCDP pilot studies indicate that civilian fatalities can only be estimated with really large uncertainty bands. So we tried doing this on data produced in the 2000s when we have a more sort of comprehensive media coverage and there's more investigatory report data available. And, in those attempts, we came up with estimates somewhere between 30 to 60% of reported fatalities were civilians. And that, is from a limited pilot study. They shouldn't be cited because what we really came up with was it was really too difficult to set even broad bands on these estimates. And those estimates also are only for reported fatalities, right? So fatalities that make it into the public arena through media reports or other types of reporting. And there may be systematic features to which fatalities become public, right? It's possible that civilian fatalities are being systematically underreported or overreported, depending on the context in any given country. And so there are kind of two takeaways from this story. The first is the problem of false precision, or the tendency of numerical estimates to appear more rigorous than similar qualitative descriptions. And also the more precise they are, the more scientific they seem to the public. So precise figures can obscure underlying uncertainty if we don't put some sort of bounds or provisos on them. The other reason I wanted to share this story is because I think as academics, it feels most of the time like we're talking in an empty room. You get something published and then what happens? At best, someone cites it. So at best, we're talking to each other. But the fact of the matter is that within the field of political science or political violence, sometimes our claims are heard by policymakers, right? And a statement on the back of a book can end up taking on a life of its own and having huge consequences. And it's really unpredictable sort of what things get picked up. So we can't be sure whether our stuff is going to be read by these kinds of audiences or not. So consider this, right? If this statement that 90% of fatalities nowadays are civilians, that was foundational to a widespread belief that wars in the 1990s and the 2000s were what they were called new wars. So this idea that rebel groups in this period constituted a new kind of actor and that the violence in these wars was more brutal than in times past. And scholars with careful research have since refuted this claim, but the idea at the time, so in the 2000s in particular, was in really wide circulation, and you can still kind of find it around today. And this 90% statement really helped to buttress that argument at a time when it had a lot of traction in policy circles. And so consider also this, that in a world where policy resources are finite and interventions have to be chosen carefully for that reason to maximize their effectiveness, basing a decision on how to distribute resources in the context of civil war is altered if you believe that 90% of the victims are civilians. So if the aim is, of intervention is to minimize deaths, and if 90% of the victims are civilians, then international actors like the UN should focus on civilian protection. They should focus on securing areas for safe passage, for protecting refugee camps and IDP camps, and they should place peacekeepers in civilian areas, right? If, however, the majority of conflict deaths are combatants, then to reduce fatalities, these international actors will be better off putting their time and their effort into mediation, negotiation, and they should deploy peacekeepers to be interposed between warring parties to prevent fighting. So these are very different policy strategies, and which may have dramatically different consequences for the people living in or near conflict-affected areas. And if policymakers base their decisions on bad data or bad analysis, it actually can matter. So just, lest you think I'm cherry picking, this 90% story isn't an isolated example. I'll give you one more short example. There's also a widely cited statistic that 75% of women in Liberia were subjected to sexual violence during its civil war. And there is a really excellent article describing this case by Derek Cohen and Amelia Hoover Green that was published in the Journal of Peace Research. And there they identify the miscitation of a survey study as the source of this 75% claim. And they show that the true rate of sexual violence against women in Liberia during the Civil War was more likely to be between 10 to 20%. And in the article, they talk about how the distortion of statistics can lead to a loss of credibility of international actors, right, when they get it wrong, to a sense of intractable crisis among potential donors, and most importantly, though, to negative consequences for populations. So if you raise the bar by which a crisis is defined, in this case, that 75% of the Liberian female population suffered sexual violence, that can subsequently decrease the attention and the resources directed to future epidemics of sexual violence. People will say, but it isn't like during the Civil War, at least it's not that bad, because the bar was raised. So if hypothetically speaking, and this is hypothetical, so I'm just making up numbers now. If we say hypothetically 35% of women suffered sexual violence in the post-conflict period, and we believe that 75% suffered that during the conflict period, we would think this was a decrease and the policy interventions were working, and we didn't need to maybe think of new initiatives or invest additional resources. If the true rate, however, was 10 to 20% during the conflict period, and 35% would then constitute a major increase in sexual violence, and we would need to focus attention on it, develop new policies, and allot new resources to it. So getting it right matters for how we fundamentally understand these problems. And it's important to be aware that intense competition for both funding and for public attention means that organizations, and these are organizations we draw data from, right, from their texts, and governments as well, they frequently make strong claims. And when they are able to do so using what's considered sort of hard numerical data produced by independent scholars, those claims are given greater credibility, and they're considered more rigorous in the eyes of the public. And so there's lots of incentives to use the type of data and analysis that we do for political ends. So why am I telling this story to an audience working with really technical sort of computational linguistics, natural language processing, machine learning stuff? Because as the examples highlight, right, quantification can both illuminate and obfuscate depending on how it's used. So when people hear scholars say things like, I analyzed 6 million news reports and this is what I found, they then attribute a high degree of certainty to whatever that finding is. And by virtue of the large amounts of data being processed, the claims coming out of this field are given considerable attention and credibility by policymakers and the general public. So scholarly quantification can be used to legitimize decisions and policies. So different academic sources can and do often produce quite different and sometimes sharply contradictory accounts of patterns of violence across time and space. And sources based on big data are not necessarily guaranteed to more effectively map ground truth. But that work is often credited with a higher degree of legitimacy and given more media attention and policy traction. And that's why I think it's important that all of us who work with the nuts and bolts of data analysis on political violence, particularly with big data as a field, maybe we need to police ourselves a little bit more carefully than we're doing right now, because we do have an ethical responsibility to get it right and to be very careful with the claims that we make. And here, perhaps I think the language we use with each other can sometimes, unfortunately, be misunderstood by non-experts when they get a hold of it. So if a report states that 96% of the events were correctly classified using X model, this sounds great from the point of view of a classification prediction exercise, but there are broader implications to that kind of statement. One is that misclassifying even just 4% of events may be consequential down the line for the kind of analysis that is conducted on those data. So if social scientists like me get our hands on them and want to start studying them to explain things, because political violence data sets tend to actually be quite small in size, which means that misclassified data can have a heavy influence on the results of statistical analyses that use those data, right? And can lead us to draw incorrect conclusions about relationships between phenomena. So even if you guys are annotating raw data, at the report level, maybe you're creating events, and these can be huge numbers of texts or events, but conflict scholars are rarely able to conduct statistical analysis at the event level. We tend to have to aggregate events geographically and temporally. So a country year analysis, or say a subnational region, month or week or day or whatever. And we do that because to be able to study the relationship between various phenomena, so like peacekeeping troop deployments and violence, or spikes in food prices and protests, we need data on the other thing as well, right? The spikes in food prices or the peacekeeping deployment. So what that is to say is that, your data is probably, if someone like me gets a hold of it, it's going to be aggregated into a much smaller data set, and then that can introduce quite a large amount of error into each of those observations. And in the worst case scenario, that error isn't random, right? That the data are classified incorrectly in a way that is systematically correlated with the phenomena we're interested in studying, resulting in bias. So, if reporters aren't able to go to the places where the violence is the worst, we're going to think those places, it's not going to be public, it's not going to come into our data sets. We're going to think those places are not being affected by violence, when in fact the opposite's true. It's just the violence is so bad the reporters don't get there. And even if the data are miscategorized at random, it can reduce the power of our statistical models as a result. So the first issue regarding that is sort of the downstream consequences for statistical inference. And the second, which is, I think, very probably remote for you guys, but I encounter with my work with UCDP, is that sort of any misclassification at all can have political consequences, and it can undermine public trust in academic work. So given the sensitive political nature of these data, particularly fatality and victimization data, it's really essential that every data point is as accurate as possible. So, when I worked with UCDP, people would contact us, quite upset about a single data point or single classification, with which they disagreed. And, it has definitely happened many times or multiple times that we've been visited by like an ambassador who takes issue with our work. And so while some errors are inevitable, too much is unacceptable. And I suspect that we think differently, machine learning scholars and social science scholars, about what we mean with acceptable, sort of beyond technical terms. I think once you've had sort of ambassadors in your office complaining, or people from the countries that you're studying kind of talking about how you've misclassified something, you start to kind of calibrate those mistakes differently than if you're just thinking about it in methodological terms. And you start to understand that these data points are events in people's lives and they have political consequences. and that there is really a kind of an ethical imperative to do better by these people. And so, you know, this is a bit of the overview of the problem, and there is a discussion about, you know, sort of at the ethical imperative to get it right when it comes to machine learning in other arenas. So, you know, we've seen in the past years, lots of well-publicized stories in the media about bias in artificial intelligence, right, which have resulted in all sorts of discriminatory outcomes in the real world, right? Amazon's AI tool was for hiring was scrapped because it showed bias against female job applicants, despite developers explicitly excluding gender. Google algorithms built to detect hate speech online were shown to have built-in biases against Black people. These are some, you know, prominent examples. There's even more egregious ones out there. And this kind of bias can arise from different phases of the machine learning process. It can be the result of original data that you're using in the model, sort of the old adage of garbage in, garbage out. I think the problem is, though, that data quality is often an unknown quantity. We actually don't always know how good the data are that we're using, and understanding sort of the validity of any data source to represent the ground truth really requires extensive expertise in the field. And, you know, researchers specializing in machine learning have tools to evaluate certain features of data quality, but they often don't have the domain knowledge necessary to evaluate whether the data are problematic in terms of how they were generated, how they became public, how did these texts come into existence, and whether that data generation process could result in bias. And at this workshop in particular, I think because of the topics that you all are researching, you're likely to be working with unique and messy data on complex and difficult tasks. And that may mean that bias is particularly challenging to identify. Bias can, of course, also be the result of human annotators who label the training data, right? In the Google case, researchers found that the people who were labeling whether a tweet was toxic or not tended to flag tweets written in African-American vernacular English as offensive. And then the bias was then propagated down into the algorithms. And I think most of the ethical problems with sort of machine learning approaches that have made it into the media have come from the corporate world, which makes sense given the massive impact they have on people's lives. But of course, similar problems can obtain in academic work. And we also receive, you know, arguably much less scrutiny than big companies do. And many of the different types of political violence data that researchers are applying machine learning approaches to, so social media data, news media data, rebel or government communications, government archival data, often tend to reproduce a single narrative or a single kind of perspective on sort of the violence itself. And if we don't recognize this, academic researchers may unwittingly lend legitimacy and lend credibility to a particular political perspective when reporting the patterns derived from those data. Pretty much every reporting organization that we draw data from have their own mandates that mean that the data they generate is not a random sample of the ground truth. So if we take organizations like Amnesty International, Human Rights Watch that generate reports, they focus more on state perpetrators than non-state actors. They also tend to focus attention on the worst cases in order to increase the impact of their advocacy. And there's a small but growing body of research that highlights similar and related problems with media reporting as well. So these kinds of dynamics mean that if we assume that texts are representative of the ground truth, we're not going to get it right. And everybody studying political violence, regardless of their methodological approach, is challenged by these issues relating to data availability, bias, and the potentially serious, sort of consequences of our work downstream. And unlike researchers who work directly with people, people who are conducting interviews or administering surveys, those of us who do desk research are rarely asked to consider the risks and the implications of our work from the perspective of research integrity and ethics, right? Desk research is typically exempt from formal mechanisms of ethical oversight, like internal review boards, because it doesn't involve direct contact with people. But as some of the examples I brought up show, our work may have downstream effects on people's lives, and in particular, the lives of some of the world's most vulnerable populations, people who belong to marginalized communities and who are exposed to war and human rights abuses. So our challenge then is to ensure that we as individuals and as a community are really self-critical and transparent about the uncertainties in our findings so that we don't mislead the people who consume our research. Otherwise, we're not acting ethically. So with that said, I'm going to now propose some suggestions on how we can go about mitigating this problem to some degree. So one step that we can take and should take is to conduct a written ethics assessment for each of our projects, where we just sit down and write it out. And I think the writing is important. And I confess that in the past, I have not done this. I have tended to kind of do these ethics assessments only when I'm preparing to work with human participants. But over the years and over working more and more with desk research, and as this talk illustrates, I think there are really important reasons to address ethical issues explicitly, both before and after undertaking desk research. And the sitting down and the writing up is important because it forces us to clarify and really think about the data production process and to interrogate it for potential flaws and biases. Where are these texts coming from? How did they get into my computer? And it forces us to learn more about the data that we're analyzing and how they were generated. It also provides sort of a framework for considering, the possible downstream consequences of our research results. And if we don't have to sit down and write it out, I think there is an inclination to just sort of grab whatever data are going to be most useful for whatever modeling exercise we're engaged in and to analyze it without considering the implications of doing so. And so, sort of writing it down also increases transparency and accountability because it can be shared easily with other people who want to engage with our research. So you can append an ethics statement to publications, or you can provide it in supplemental online files. And, what I'm suggesting is something that takes time, right? It's work if you're going to do it seriously and carefully. You need to maybe read documentation about the raw data sources. You need to consult literature about the data generation processes. Maybe you need to correspond with people who were involved in the creation of the data. And that's, that all involves work. So for example, I conducted a project on police assault claims in Sweden and the sort of prosecutorial decisions that were taken about those claims. And before analyzing the data, some of the sort of preparatory work that I did was to read all of the government documentation, so all of the reports from the prosecutor's office. I read academic articles about sort of the Swedish prosecutors and the police assault claims so that I could better understand the context in which these decisions that I was going to analyze took place. I corresponded with the head of the prosecutorial agency that produced the texts that I analyzed. I did that all to sort of understand better how the texts were generated. How did these cases get there? Who were these prosecutors who were making decisions? How were they assigned the cases? And so on. And I also read a sample of the data, not for the purpose of annotating or for creating training data, but just to be able to understand the broader dynamics in which the data were occurring. And that's obviously all a significant investment in time. For me, I think it pays off in terms of gaining a richer understanding of the data, which is essential for addressing the kind of ethical issues I'm raising here, but which also has the added benefit of often helping to shape and improve the modeling process itself. And so, to be clear, the objective of the task sort of isn't to model the uncertainty, but rather to generate more qualitative contextual knowledge of the data generation process in order to produce sort of nuanced views about potential biases that can be then used when drawing or refusing to draw conclusions about, our research, and to be able to communicate with the consumers of our research. So that's the first strategy, a written ethics assessment. It doesn't have to be long, but I think it needs to be thoughtful. The second mitigation strategy that I would propose is to consider especially the issue of communication. So as scholars working on sensitive, politicized topics, we need to think carefully about how our results are communicated, especially to non-academic audiences. And in particular, non-experts are most likely to access your research through abstracts or through press releases. So I think those are sort of the venues where we need to be the most careful. And of course, I know that we're all writing abstracts for academic audiences, right? Where we need to put in certain technical information on methods and main findings, but you can also use the abstract to signal or provide sort of provisos to the conclusions that you're drawing. And press releases give you even more opportunity to qualify your findings and signal some sort of, concerns about the competence in the results or limitations or boundaries for those. Because we cannot be sort of too explicit in setting the bounds for the claims that we make. The public just doesn't have the domain knowledge or the methodological knowledge to understand the problems and the pitfalls of the kind of research endeavors that we're engaged in. And that means that we have an ethical imperative to be extremely careful in how we phrase our findings, because the public is not equipped to evaluate us. And that means that it's really essential that we're transparent about these potential underlying problems and biases with our data. I don't know if this is common in your field. In my field, it's common. So in political science or social science, it's common to end our publications by discussing sort of policy implications of our work. A lot of my students tend to do this when they're writing their master's theses. And the advice that I always give them is to imagine that someone from the UN actually did pick up their master's thesis and read their policy advice and follow it. Would that sit well with them or not? Would they really want someone to base a policy on their research results from their master's thesis? And more often than not, the answer is no. The results aren't sufficiently clear-cut or robust to warrant, any sort of real-world decision on the basis of them. And I think all of us working on political violence, myself included, would be well served by, thinking in a similar way, by assuming that someone from the UN is going to pick up our paper and read our work, or at least our abstract, and to adjust the way we write accordingly so that it can be understood and not misinterpreted. So first 2 points, right? Make a written ethics assessment, communicate carefully. And then the third point I want to make and end with is the importance of interdisciplinary collaboration in mitigating many of the problems that can arise in the context of getting it right. So I think one natural response that I would anticipate anyway to the suggestions that I'm presenting here is, look, I work on machine learning models. How could I possibly know what are the downstream ethical implications of my work or how these data were generated? Which I think is a fair answer to what I'm saying here. And my reply would be, we work in teams. So get someone on board who specializes in that particular facet of the work and work with them on it, right? We all specialize and we work in teams to sort of maximize what we can do by using our relative specialties. And I think collaboration with social sciences specializing in political violence can help provide the type of contextual information that I've been discussing as essential to being able to evaluate bias, right? Sort of topical distance can lead researchers to misinterpret results or to generate analysis that's kind of untethered to social contexts. So bringing social scientists onto the team can contribute insights into the data itself, as well as how the analysis could potentially be translated into real-world implications later. So, in a sense, bringing in a social scientist may help you to transform unknown unknowns into known unknowns, right? Their kind of topical knowledge can help you to perhaps identify blind spots about these issues. And, I would argue too that if classification projects that generate new data, especially, are to be useful, ultimately for understanding political violence, then they should actually probably be anchored in a dialogue with the scholars who put them to use analytically to study these phenomena. Because otherwise the data won't be used aside from improving machine learning models. But, ideally you want to do both, right? You also want those data to be repurposed in another venue to better understand political violence as a phenomena. I'm assuming there are some sort of internal motivations for why you guys all chose to work in this kind of field. And if I'm a little bit provocative, of course, we all have professional incentives to publish. And that includes using cutting edge techniques or solving a hard problem or providing sort of any new data set. And all of those incentives sort of trump, I think, whether, it doesn't necessarily mean that you're creating usable data from a social science perspective. And I think, that there should be maybe more of a discussion about how our individual professional incentives can and should be balanced by more discipline-wide norms that elevate ethics to ensure that there is actual meaningful social value to the kind of work you're doing, to sort of ensure that that's anchored. So the Leading AI conference, which maybe I'm going to pronounce this wrong, NeurIPS, I think is how you pronounce it, now requires every submission to have a broader impact section. And it also employs experts to evaluate some of these broader impact sections, the ones that are maybe a little bit more in the gray zone, I think. And there's stuff to unpack about that policy. I'm no expert on it, but I think that policy highlights a number of the points that I've been making about the need for sort of ethics and domain knowledge expertise within each of these projects. And for engaging in transparent evaluations and for communicating it. And I think the NeurIPS example also shows how gatekeepers within the discipline can kind of shift norms towards more ethical practices. Of course, the obvious risk is with these kind of policies is that individuals will see it as a formality, right? Just a box to be ticked, unless they understand why ethics are important in their work and they sort of engage with that in a meaningful way. So to round off, helping you to kind of appreciate that why has been my goal today, maybe with some stories you haven't heard before. And my objective is a bit to wave a red flag about some of the pitfalls of getting it wrong. But I also want to acknowledge, as I sort of close my remarks, that machine learning approaches, also allow scholars to exploit multiple sources and multi-language sources to an incredible degree that is much greater than has ever been possible. And in doing so, of course, increase our ability to get it right. Oops, what's happening? Okay. And we can, better mitigate some of the biases that we know are associated with using only English language sources or only international news bureaus with these tools. And, some of you here are using, machine learning tools to probe these biases that I've been talking about, trying to understand the differences in the way news reports originate between countries. And that's fantastic. So I want to stress, as I'm rounding off, that the point of my speech is not that machine learning approaches are inherently more likely to get it wrong. Everyone studying political violence risks getting it wrong. My goal here is to raise awareness about what I think are often invisible to us real world implications of our work that can occur and the ethical dimensions, that may have. And I think, seen in the context of our roles as researchers in societies, we're bound by a higher level ethical imperative. With, this adage of with knowledge comes power sounds trite when you say it, but if you consider it, machine learning is a highly technical scientific endeavor, which makes it, in most ways, kind of a closed system. Evaluating your work and your claims requires specialist knowledge that very few people possess. And so there's really a responsibility on academia to police itself, both as individuals and as a community. And so I think with that, I will draw this to a close and thank you for your time. And yeah, I'm curious to see if you have any questions about that.
Thank you very much, Kristine. Do you hear me? It was really quite like raising awareness. These just a comment before I ask the audience for any comments or questions. In computational linguistics as well, there has been like trying to make it as clear as possible how the data is collected. So specify it as good as possible with what purpose you collect the data and all these additional details. And data statements are suggested with a certain format by Emily Bander and Batya Friedman. And we are working on it. It is a really not just NeuroNIPS. ACL had these sections recently, last 1 or 2 years maybe, and it asks the reviewers as well to highlight any concerns in this line. So as you say, the more power, the more responsibility, the more risks. So we need to work on it all together. So any other comment or question, guys? Please raise hands.
I can say something while people are thinking, and that is, I think with data collection, there's 2 levels to think about, right? So there's the data that we select and we choose and we collect as scholars to work on. So I'm gonna, you know, I'm gonna work with this set of articles or this set of texts or this set of, you know, documents. But then there's also the question of, you know, among that set of choices that we make of why did I choose this data, there's the process that generated it in the first place, right? These ground sources. And, you know, when we think about news reporting, so in a news article, we look at not just, you know, where's the news article coming from? So is this, you know, a local source, an international source? What language is it in? There's also, you know, who is the source for the information in the article? So is this coming from government statements? Is it coming from eyewitnesses? So there's so many layers in terms of working backwards for every piece of information in terms of where it came from.
Yeah, so it is not just a computational thing, I agree. Not just a computational thing. So, Andy has a question or comment?
Yes, I really enjoyed the talk, and I wanted to hear your thoughts on something that I've faced sometimes in my own research, as mostly a social scientist who also does NLP, which is oftentimes the accuracy of our models sort of correlates with the source and the perspective of the source. So, for instance, in my work on Syria, articles written by the state news service are very well edited, and if you put them into Spacey, you get a beautiful dependency parse that all makes sense. If you put in opposition newspapers, you get much worse results, and of course that has implications for our understanding of the conflict. And I've wondered about how what the best way to convey the possible inaccuracies and those the correlations of accuracy and source in the final conclusions. And I'm just curious to see if you've thought about sort of how to convey that level of uncertainty, or how to appropriately caveat it, both in terms of text, sort of in the discussion around the figures, but also maybe in the figures themselves.
That's a super hard question, and I don't have a good answer for you. And you know, to a certain extent, it's really on a project by project basis, and to a large extent, our hands are completely tied, right? It's a difficult topic that we're studying. Data availability is really sketchy. We have to make do with what we have most of the time. So I think the takeaways are really more about trying to signal uncertainty and signal in various ways that there can be bias in what's going on, or uncertainty in the data generation. I think the point you make about figures is a really good one, though, because in addition to the abstract and the press release, the figures are also the other things people are likely to consume, outsiders especially are likely to consume. And, aside from trying to stick something in the note, which may be awkward, more or less, depending on, what you're writing, I don't really have a great suggestion for how you kind of sneak that into the figure so that a novice, who isn't an expert in this field would understand, look, this graph is working on the assumption, though, that the data are the same when they're not, right? But I think you're absolutely right that that figure is actually really important to that as well. And I don't know really what we can do beyond signal in some ways, somehow. So we at least tried. And then, I think there's still probably a pretty high likelihood our provisos and our, academic nuancing gets ignored, right? But at least we give it a try to do that. And the people who are really interested will find it and hopefully, make more of a debate.
Maybe I can add to from like last recent developments from machine learning, like Elizabeth suggested, like with the cutting edge deep learning models or transformers, we have the means to focus on the information and leave the dependency trees aside, or user generated, less formal writing. So this may provide us some hope, but it must be measured well, whether it really helps to get the information there equally right, maybe. So, any other comment or question? Okay, thank you very much, Kristine. It was really great to listen to you. And now we have a break, let's say until 4 UTC. Then we will listen to the regular papers from the workshop. I'm looking forward to have you as well. So they are great papers, like selected from 21, 7 are the best. So I read all and was amazed about all this stuff. Okay, see you in 15 minutes. I will not log out, just will have 5 minutes and be around again. Bye-bye. Hi, everybody. We are in the second session. Normally, Lifu Huang from Virginia Tech was last minute. He said he will not be able to. Some other stuff may arise. So I will chair it, me again. We will start with Tommaso Caselli. He will present the paper Protest There, Retraining BERT for Protest Event Extraction. Thanks to him, he collaborated with us on this. So it was a great work, and looking forward to have it presented by Tommaso. Welcome, Tommaso.
Hi. Okay, so I'm going to share my screen now. And so you should see the main slide. Okay, so let me see if are you seeing that full size?
Yeah, we see the
Great.
full screen.
Great. All right. So I think I can start. Yes. So protester retraining BERT for protest event extraction, and as Ali was saying, this is a joint collaboration with Osman, Mutlu, Angelo, Basile, and Ali. So I want to start with a reflection about portability and robustness of natural language processing systems. These two aspects are actually still some sort of major pending challenges. And however, the development and the availability of pre-trained language models has had a positive impact to address these challenges. In a way, we can think that fine-tuning has contributed to robustness, and the success of in zero-shot transfer of these pre-trained language models has in a way contributed to improve the portability of these of the tools in general. However, pre-trained language models have been developed using data representing varieties of languages that sometimes are not suitable for all domains, or even better, for all language variety in general. This is a problem that has been addressed by the community in two ways. The first one, well, we could create domain-specific pre-trained language models, and some of the examples are, for instance, FIN-BERT or legal BERT. So you start from scratch. Alternatively, what we could do, what has been proposed, is to further train existing language model with domain-specific data, and in this way, what we are going to do is to perform an unsupervised sort of domain adaptation, which targets the problem of domain adaptation at a really at a very early stage of the domain adaptation pipeline. So what we did in this work is to we adopt the further training solution and applied it to the task of detecting protest event in news articles. Sorry. And for this, we have used the Protest News Lab data that was presented at CLE 2019. And in particular, we investigated two aspects. So the first concerns the impact of the data that is used to further adapt the language model. And in particular, we compared the performance of a model adapted with generic news data and one using news articles that discuss or speak about protest events. And the second aspect that we have investigated is the portability of the domain-adapted language model in a zero-shot scenario. And in particular, the Protest News Lab data are particularly suited or adapted to investigate portability, since one of the test sets that it is part of the data is based on a collection of news articles that comes from a completely different distribution with respect to the training data. So this really forces the models to play with the domain adaptation, unsupervised domain adaptation. Sorry. So what we did is we generated two language models. The first we called BERT News, which is based on which uses randomly extracting news data, and in particular 100,000 randomly extracting news data. And the second protester, which uses a maximum of 79,000 protest event news. And the protest event news that we have used to create protester have been automatically identified. So we did not manually look for this data. The further training data for both models have been extracted from the Washington Post corpus, the version 3. And to further train, what we did, we applied the mask language model objective to the English BERT based on case, and we keep training for 100 epochs. The table that you see in these slides actually, well, we find it interesting because it shows some similarities and differences. And we measure these using the Jensen-Shannon divergence and the auto-vocabulary rate between the retraining material, so the data that we use to further train BERT, and the test set of the protest news lab, which are labeled India and China just to distinguish them. What is interesting is that, as you can see from the figures in the table, both retraining materials are actually homogeneous with respect to the test data, for both test data. Sorry. So let's get to the results. And as you can see in the first table, in this table, sorry, we are comparing first the results of BERT, the generic BERT with no adaptation, and then BERT news and protester. And here we are comparing the three models using the first data set, which is the India test set. And all models have been fine-tuned on the official protest news lab training split, which again contains protest news article from India. So this, you can imagine that is a sort of same domain evaluation scenario. What are the results and what we have learned from these? So first, we have noticed that if we can vary the input of the representation, and if we use sentences at training stage, it is actually much better. We get better results than when using the full documents. And another things that we found interesting is that using data containing protest news gives much better results. If you look at the rows for BERT news has consistently has a lower performance, even lower than a generic non-adapted BERT model. Finally, what we have noticed that overall protester results in a gain of, on average, 11.74 points when compared to BERT. And when we apply the retrain, so the adapted model to the out-of-domain test set, which can be called the China test set. So basically, it still contains news articles about protest events, but now these are protest events in China. What we can see is that protester obtains better results also when compared with respect to the generic BERT. We didn't run any experiment using the BERT news because the results were way below the expectation. And the biggest drop that we have, so basically protester results in a much better portable systems. And the biggest drop that we have observed affect the arguments, and especially those arguments that express domain-specific properties, such as name of places and the name of protest organizers. Okay, so to conclude, in this work, we actually confirmed that further training is an effective method to adapt to new domains and also to different language varieties. And these improve performance on generic language models. Although the quality of the data used to further train the model is really important in this respect. And the domain adapted model results in better portability than the corresponding non-adaptive one. And a final aspect that we have observed is that the domain adapted models actually need less training data in order to boost the performances of the system. And that's it. Thanks. I will be happy to take questions.
Thanks a lot, Tommaso. So do we have any comment or question or happiness about having this model? Tian Cheng, who raised a hand.
Hi, thank you for the presentation. I find this very interesting, and this is in fact something similar to this is what I did for the shared task, and it resulted in very good performance. And I also noticed how, when you further fine-tune your model on the generic news article, the performance in protest news classification dropped like by a lot. So similar to what you observed. So I wonder, do you have any insight on what the reason that might be? Is it just because the data is too different from protest news, or?
So that was so this was the first thing that we started speculating. We saw the results and we said, yeah, the data definitely are different. But if you somehow remember the figures in the where we use the Jensen-Shandon divergence, so similarities and differences between the retraining materials and the test data, the news, the generic news, it was not that much different with respect to what we call the protest news. So I think that what happens is that first you adapt to generic news domain in general, and then the fine tuning is going in a different direction. So it's more domain specific. And so I think that these sort of differences between the retraining material and the fine tuning material that you have for the shared task is the one that creates these drop in performances for the BERT news generic model. It is more a speculation than data with good evidence. Hope this answers your question.
Okay, thanks.
Yeah. Any other question or comment? So thank you very much, Tommaso.
Thanks.
And hope to see more of this great work. The more with us is, the happier we are. So next we have Debanjana Kar. She will tell us about ArgFuse. It is actually the title is quite descriptive, so let me read the title: A weakly supervised framework for document level event argument aggregation. So welcome, Debanjana. I hope I'm pronouncing it well. And please, are you there? I got a confirmation, but.
Sorry, I was on mute. I didn't realize. Hi.
Welcome. Thanks for coming and contributing to the workshop.
Yes. Thank
Floor
you,
is yours.
Professor. Thank you, Professor Ali. I'll share my screen.
Sure.
Let's start the timer. Is my screen visible?
Yeah, we see it.
It's full screen, right?
Yeah, now it is quite nicely shown.
Okay. So, hi everyone. My name is Debanjana Kaur, and I'll be presenting our work titled ArgFuse, a weakly supervised framework for document level event argument aggregation. So this work has been done in collaboration with my mentors, Professor Sudeshna, Sarkar, and Professor Pawan Goyal from IIT Kharagpur, India. So just a brief intro about what motivated us to take up this task. So extraction of event argument information at a document level is an important, non-trivial task. But what we have observed is that most of the existing event argument extraction systems, they mainly pertain to a sentence level focus. So what we wanted to do is we wanted to build an event argument information aggregator at a document level. So we do observe that there are some document level event argument extraction systems which are already there. And but the task of document level event argument extraction, it does not involve explicitly checking for relevance and redundancy. So that is why we introduced the related task of event argument aggregation. So just to briefly talk about what event argument aggregation refers to. So in event argument aggregation, given sentence level event arguments, we aim to filter the arguments which are contextually irrelevant and semantically redundant. And we want to basically render a precise document level information frame with minimal loss of information. So this will be even more clear if you look at the example we have on the right. So we have a document from our corpus, which talks about a cyclone which has happened in Indonesia. So over here, you can see that there are some phrases which are highlighted in red, green, and blue. The phrases highlighted in red, they are basically redundant argument mentions. The phrases highlighted in blue refer to the irrelevant argument mentions. And the phrase which is highlighted in green, it refers to an exclusive argument mention. So basically, those argument mentions which disseminate only unique piece of information. Now, if we talk about the irrelevant argument mentions, they usually refer to past or future event records. So for example, over here, if you look at the last line, it actually talks about a landslide which took place in Bali. And the time at which this took place is at a past time reference than the time this document is talking about. So that's why it constitutes an irrelevant argument mention. The redundant argument mention, we see that redundancy manifests in different forms in the corpus. And we identified 4 different forms of redundancy which occurs frequently in the corpus. So the first one is duplicity, that is the same argument mention occurring more than once. The second is similar surface form. The third one is reworded, that is when argument mentions are paraphrases of each other. So as we can see over here, death toll more than doubles to 41 and killed 41 people. And the fourth one is subsuming information. That is when one argument mention subsumes the information of the other. So for example, over here, we can see that in this storm event, basically 41 people were killed. And if we look into the body of the document, we can see the phrase 25 people killed. Now, these 25 people were killed by a landslide, which was triggered by the cyclone. And these 25 people are part of the 41. So when we are preparing the document level information frame for the casualties argument type, we will be basically looking at killed 41 people, and 25 people killed will be a redundant argument mention. So with this in mind, we will now look at a high-level overview of the approach that we propose. So given documents, we will first extract the sentence level arguments. Now, the focus of our work is not how to extract sentence level arguments. So we can use, this is a very modular approach, and you can use any sentence level event argument extractor in this place. So we have used a state-of-the-art sentence level event argument extraction system for our data set, which I've referred to in the slide below. And once we have the sentence level event arguments extracted, we enter the crux of our work, which is the aggregation unit. And the aggregation unit mainly comprises of 3 main submodules. So the relevance filter, the argument ranking module, and the redundancy filter. And the output of this aggregation unit are the document level arguments, which constitute our document level information frame. So we'll be talking about each of these submodules in detail in the next slide. So for the relevance filter, in this submodule, we basically contemplate whether an argument is relevant to the topical context of the document or the event of the document. So we see that context is very crucial to identify the argument's relevance. And what we basically do in this submodule is basically fine tune the Robota model. And the input of the model is the event type of the document, the argument type of the document, the argument phrase, and the document context. And the input to the model is in a format as shown over here. So since we are proposing a novel task, we did not have any data to start with. So all the data that we'll be using here has been manually labeled by us. So for this task, we had 500 labeled instances for training and 100 labeled instances for testing. So with that, we look at the redundancy filter now. So if we revisit the table that we were seeing just a few slides back, we can see that among the 4 redundancy forms that we identified, the first 2 forms are easily identifiable, and they are quite explicit in nature. So we refer to them as the explicit redundant argument mentions. And as they're easily identifiable, we use Levenshtein distance and cosine similarity to detect explicit redundant argument mentions. The third and the fourth redundancy forms are the ones which make for a more complex case. And these are the forms where we cannot simply use an unsupervised mechanism or any rule-based heuristic. And we would require some supervised mechanism to detect these redundancy forms. But as we said, we did not have any data set. So manually labeling all this would be quite taxing. So if you look at the next slide, we'll see that in our data set, we had around 7,000 argument pair instances. And to label them would be expensive, time consuming, and definitely not very feasible. So that is why we adopt a weakly supervised approach, and in this case, active learning. So what we do is we start with a small set of samples. So we label 1045 training instances. And in each iteration, we identify 50 challenging points from the unlabeled pool of instances. Now we identify the 50 challenging instances by using the Monte Carlo estimation of error reduction, which is basically this entropy formula that we have over here. So once we identify the 50 most uncertain samples, we manually label them and then add it to the existing labeled training set again and repeat the process iteratively. So this is what we do in active learning, and we train actively for around 5 iterations until we don't see much difference in the F1 score in consecutive iterations. So once this has been done, we train the model further for 15 epochs and on the final data set, and that is how we have designed the redundancy filter. So the input to the redundancy filter is pretty similar to what we had in relevance filter. And over here also the input is the event type of the document, the argument types of the argument pair that we are considering, and the document context. And the embedding on the word embedding that we have used here is BERT. So if we look at the entire model, if we stitch together everything now, so we have the trained relevance filter, we have the trained redundance filter, and during inference, we have the sentence level arguments, which we first classify as relevant or not. If it is not relevant, we reject it. If it is relevant, we collect a pool of relevant argument mentions, which we then rank based on informativeness. So the ranking strategy that we use over here is biased text rank, which was recently published in Polling 2020. And I will not get into the details of biased text rank over here, and I would like to refer you to our paper where we have explained how we use biased text rank to rank the arguments for our approach. So after that, once we have ranked the relevant arguments, we consider each argument pair and classify them whether they are redundant or not. If they are redundant, the argument from the argument pair, which has a lower information score, the score that we obtain using biased text rank, basically, we reject the argument which has a lower score, and we continue this process iteratively until unless we have considered all the argument pairs. After that, we have a post-processing step, which finally leads us to our list of document level arguments, which comprise our document level information frame. So before we look at the results that we have got from our proposed approach, a little intuition about the data set that we have used. So the data set, so we mainly have around 33 event types at a fine-grained level, and at a higher level of abstraction, we have around 14 event types, and there are around 12 to 14 argument types which are there, but the main argument types that we have focused in our work are 6 main argument types, that is time, place, casualties, after effects, reason, and participant. Now, when as we have already mentioned, we did not have any labeled samples, so we have proposed a weakly supervised approach. For testing our algorithm, we have manually annotated 131 document information frame, and the data set looks something like this. So just a few terminologies to better understand the work. So the sentence level argument mentions have been referred to as unmerged argument mentions. The merged argument mentions refer to document level argument mentions. Singles refer to a category of argument roles which constitute of a single argument mention that has been highlighted with red. And multiples refer to a category of argument roles which constitute of more than one relevant argument mention that has been highlighted in blue over here. So some quantitative analysis of our data set. So if we look at the first figure and we look at the sentence level and document level distributions, we realize that redundancy and irrelevance is quite prevalent in the sentence level information. And if you look at the second figure, we can see that although a major number of argument roles are constituted in the singles category, but multiples constitute a significant number of argument mentions as well, which brings us to the point that the number of relevant arguments for a particular argument role or type can be flexible, and the model should be able to accommodate that flexibility. So these are the scores for the piecemeal classifiers, that is the relevance filter and the redundancy filter. And this is the results for our aggregation model that we have proposed. So we compare it with Give Me 5W1H, which is a rule-based document level event argument extraction system. Text rank, biased text rank, which are very popular unsupervised algorithms, which has been successfully employed in different NLP tasks like keyword extraction, then focus summarization. The major disadvantage of text rank and biased text rank in our case is that the number of outputs required from these unsupervised mechanisms like text rank and biased text rank needs to be mentioned from before. So in our case, the number of relevant and the number of document level argument mentions that we want to extract for each role needs to be mentioned from before, and that is not feasible, as we have already seen in the previous slides. So that becomes a hurdle, and that flexibility is provided by our model. So if you look at the numbers over here, we can see that biased text rank at k equals 1, k is the number of argument mentions that we want to output, which we need to mention before. And the precision and recall scores are highest for these two settings. But our model gives a nice balance between these two scores, and it reports the highest F1 score for this task. We also provide argument-wise results, and over here what we do observe is that the bias text rank at k equals 2 and ArgFuse results are usually comparable, or in sometimes ArgFuse gives a better result for some of the arguments. So we have also done qualitative analysis, and we have more examples in our paper. Okay, no, not for this one maybe, but we have shown over here that the output of the various baseline models compared against ours and human level result. So what we can see is our model is effectively can remove redundancy and irrelevance from the output, and the highlighted arguments over in this table are basically those arguments which overlap with the human output, and we can see that the most amount of overlap is with our model's output over here. So finally, we analyze the merits and demerits of our approach, and we can see that, so if you look at the merits, it's a weakly supervised algorithm. It's not a data hungry algorithm and doesn't rely on a large analytic corpus. The number of relevant arguments to be extracted need not be pre-specified, like it needs to be pre-specified in bias text rank and text rank, and it can be extended to multiple languages. The demerits are that the error propagates through the different modules, as it's a modular approach, and the pre-trained model cannot directly be applied to other languages. So we have experimented in English, and the models that we have are trained on English. So that is one drawback that we have. So finally, the key takeaways. So we propose a novel task of document level event argument aggregation and establish baseline for the same. We propose a weakly supervised model to aggregate event arguments, and we release the first event argument aggregate dataset for this task. For future work, we want to improve the aggregation capabilities of the model. We have always experimented with one type of active learning strategy. We want to experiment with different active learning strategies and see which one, if there are any other strategy which gives a better result. And we definitely want to extend it to accommodate more languages. So with that, I come to the end of this talk, and the code and the data has been open sourced at this link. And if you want to contact me, you can contact me on this email ID. So thank you so much.
Thank you very much, Debanjana. It is quite interesting to see how all these arguments can be summarized and selected. And it came to my mind like how it would behave for multiple documents, but the study is limited anyway. But it really opens interesting lines of research. So do we have any question or comment? We have time maybe for one.
Yeah, I have one comment. Actually, the work on multi-document event extraction has been done already 20 years ago. Maybe it would be worth mentioning it in this context, like the event extraction system developed by the University of Helsinki, PALS, or the event extraction system developed in ISPRA, in the Joint Research Center. And it would be interesting to compare actually how this approach compares vis-a-vis extracting information about events only from the leading part of news articles when you have a reporting in more than one document. Thank you.
Yeah, thanks for the comment, Jakub. When I read the paper, I remembered this one. So I was working in this group, so I know what they do. It will be really interesting comparison. Jakub, could you please put some URL or titles about this work? And it is called a slot filling, right? Maybe some key terms.
Yeah, I will provide some links in the chat.
Thank you very much. I was myself wondering as well, which one is the most canonical example of these approaches. So, Debanjana, any last words you like to contribute or?
Yes, so regarding that, so like right now we have done the work at a document level. Yes, it would be very interesting to see how this fares at a cross-document level. And definitely, I'll keep that in mind. That's an interesting point to note, definitely.
Thank you very much. So we have the following presentation from Sander Bijl de Vroe on modality and negation in event extraction. Another interesting study on different aspects of the pure event extraction line of research. Sander, are you there?
Hi, yeah, can you hear me?
Yeah, welcome. Thanks for
Cool, I'm just gonna try to share my screen.
Sure.
Let's see, does that work?
Yeah, we see it.
Cool, great.
It is perfect.
Yeah, so my name is Sander. I'll just get right into it. We've been doing ongoing work on modality and negation in event extraction. And this is a joint work with Liane, who is also first author, and with Milos and Nick and Mark. Yeah, so as an introduction, I wanted to go straight into an example. So if you have an event extraction system and you're using it to do question answering, and you get a question like, did the protesters attack the police? Then your answer is going to depend on the shape of the evidence you see, right, in text. And here the example on the right has a modal operator that scopes over the event, so unlikely to attack. And we need to understand this to understand the event and to give the right answer, which is that they probably didn't attack. So we think that modality is very important to event understanding, and it's often overlooked in this type of open domain extraction. And so to help with this problem, we created a parser that does open domain extraction and does modality tagging. And we also share a lexicon of words and multi-word phrases that can trigger modality. And then finally, we do a corpus study on the politics domain and also the general domain of a large corpus of news text. So what are the phenomena we're actually dealing with here? We have basically anything that a speaker can use to indicate that they're uncertain that an event actually happens. And that can be conditionality or counterfactuality when the speaker is in some sort of possible world that they're describing, or modal operators like the modal verbs or other categories. And then there's negation with function words like not or never, or lexical negation. And finally, propositional attitude, where you have an entity attributing a thought to some other entity about an event that might not happen. And so we're interested in all of these because they might mean that the event isn't actually occurring in the real world. And so we compiled a lexicon for this purpose. The base of the lexicon is a modality lexicon by Baker et al. And we added to this some reporting verbs from another resource to cover these propositional attitudes. And then we added conditionals and some other bits and pieces from a resource by Soma Sundaram. And we also used some of our previous work where we had a collection of events that were mentioned as happening at the same time, but actually couldn't. And many of these happen to involve modality somehow. So we took all of these and we put them through WordNet to get synonyms and antonyms, and did some manual annotation to basically keep everything that was useful. And that left us with about 500 entries. And that covers everything except counterfactuality, which we do with rules. So that's modality, these attitudes, conditionality, and the negations. Let me just hide this. So we build this on top of an existing event extraction pipeline. And the pipeline takes as input basically just raw text, so sentences, and the output is a set of tagged relations. And it's built on top of core NLP and a CCG parser, which stands for combinatory categorical grammar. And we use this to construct a dependency graph that we can use to extract both unary and binary relations. And relations are of the form of an argument, a predicate, and another argument. And then on top of these, we can do some extra work to get the types of arguments. We use Ada Lite and the Figer mapping for this. And once we have all of that, we can apply our lexicon and our parser to tag the relations. A crucial step within this is translating from the syntax of the sentence to the semantics. So on the right side here, we have a CCG syntax tree. And we use a method that was proposed by Clark and others to then transform that into a dependency tree. And then we can, or a graph, and we can use that graph to then find the modality tags. So how does the parser actually work? The inputs it gets are these, the dependency graph and the lexicon that I described before and the relation. So in this case, we're dealing with the sentence, Johnson doubts that Labour will win the election, and the winning doesn't actually happen, or yeah, hasn't happened yet, perhaps. So the relation we extract is that Labour wins election. And our first step is to pass over the graph and identify all the possible modal trigger nodes for which we check the lexicon. So in this case, we hope that doubts and will are both identified as a modal trigger. And then we walk the graph to check all the paths from modal triggers to the predicate nodes. And in this case, that means that we want to find a path from doubting to win and from will to win. And then since we find these paths, we apply the tag and we eventually extract the complete relation with this extra added modal scope. So to give you an idea of why this is useful, we compare to some open domain systems that are pretty commonly used, so OpenIE and Ollie. And yeah, the issue is most clear in this first example, where you have the sentence Parliament failed to investigate the Kremlin. And our system extracts both this lexical negation tag and the full predicate with the fail to attached. Whereas OpenIE has kind of the full mistake that Parliament did investigate the Kremlin. And then Ollie extracts the contradiction of extracting both that they failed to and that they did investigate. And we also point out that we have this benefit of understanding the modal structure of the predicates we extract. So in the second sentence, we find both that there's this counterfactual winning and this modal being in. And the other systems do capture some of this, but it's kind of hidden inside the predicate in a structureless way. So we have this like had Trump won or would still be in as a full predicate, and then you can't use that for a downstream task. So yeah, we hope this makes it clear that that this is very useful to use. We did a quick intrinsic evaluation as well, where we annotated 100 of the event relations that came from the pipeline. And two annotators labeled these for the events being actually asserted by the speaker or the writer, or whether they were still uncertain somehow. We got an agreement of 0.77, which is high enough. And we found that performance was fairly strong. So we had F1 on the micro average of 0.81, which we found useful enough to use then for other experiments later. And we also did an error analysis and found that the biggest problem was in the CCG parsing. So if you miss a link in the dependency parse somewhere that prevents you from drawing this path, then you can't recover the modal tag. And there were also some issues with the lexicon not having enough coverage or not taking enough context into account, and a couple of human errors as well, unfortunately. then we performed this corpus analysis, and we applied the parser to a corpus called NewSpike, which consists of about 500,000 articles. And we split this into a few domains, with the politics domain being identified by having a sufficient number of political entities in the text. And we found that on this subdomain, the subdomain was about 10% of the total data, and the majority was sports data. And then when we apply the tagger, we found that the politics domain had the biggest proportion of modal tags. So it's just over 25%, whereas the others are a bit over 20% modal relations. And then the distribution of tags was fairly similar between the three different domains. But for politics, you can see that the bulk by far are these modal tags, which are also most common in the lexicon. And the rest are fairly rare, apart from this attitude say, which makes sense for the news domain because there's many reports of politicians saying such and such, or organizations stating that they will do something. And yeah, there's a lot of interesting future work to do here. We're currently working on a contextualized language model that is aware of modality. And this is interesting because modality is quite context sensitive. So the triggers in this lexicon really need context for us to know whether they are modal in some cases. And also they can, the phrases that can trigger modality are actually can be quite complex. So you could say something like, it is a well-known assumption that such and such event should happen. And then because these phrases can become so complex, it's hard to put them in a lexicon. So a language model is better. And we're also doing work on expanding beyond English, since our project is also cross-lingual. And finally, we want to kind of expand the evaluation and do something extrinsic on question answering. And for that, we would need to retrain the CCG parser because it suffers on questions, or the accuracy suffers on questions. Yeah, and so to conclude, I've presented Monty. It's our event extraction system that handles all these semantic phenomena, the modal operators, conditionals, counterfactuals, propositional attitude, and negation. And for this purpose, we made a new wide coverage lexicon that we make available. And we get relatively strong performance on intrinsic evaluation. And finally, we show that modality is important in the politics domain and just in news text generally. It's very common, and we think it's important not to make mistakes on that. So with that, I just want to thank my collaborators. And yeah, I welcome any questions.
Thank you very much, Sander. I'm not seeing. Wow. So do we have any questions? Thanks for the presentation, by the way. It's hard to pick. You studied quite well.
Thank you. I just noticed my video was off. I hope that wasn't off the entire time. But...
We have a question from Brandon.
Yeah. Thanks for the presentation. That was very cool. I was wondering what you can say about the applications you would envision. I guess maybe incorporating into the types of event extraction you're seeing here. And I just want to make one suggestion that I could imagine that precision recall trade-offs could be useful depending on the application. And you actually can do that with your system. You already could do it even without machine learning if you have probabilistic confidences from the CCG parser. In my group, we wrote a paper doing this with dependency parsers, but I think you could do something quite similar in your framework. I don't know if that's useful for what you're doing, but just a suggestion.
Yeah, that sounds very cool. Yeah. And we've been using this on downstream tasks. We've been using it recently on entailment graph learning. And we're also planning on using it for question answering. And for question answering, we definitely think it's going to be useful, especially if we can create a data set that's kind of rich in these modal descriptions. For entailment graph learning, the message seems to be more mixed. At the moment, it seems like it's actually often useful to have these modal relations around. And in some cases, it's useful to parse them out. But yeah, definitely, I think for many downstream tasks, it can be useful.
Well, thanks. If I can ask one follow-up, have you looked at doing something like the Sari-Pustiovsky style, like fact bank type of modality or veridicality? Would your system be helpful for that in some way?
Can you remind me? I think I have come across that, but that's
okay.
like an
It's yet
annotation,
another system.
like data set, right? Yeah.
Yeah, there's all these different terms are used. It's kind of like a factuality stance, like this source is committed that this happened or is not committed that this happened, things like that. Maybe it's subsumed with some of your tags. I'm not quite sure.
Yeah, I think, we came across a lot of definitions that like kind of, there's like this Venn diagram of overlapping terms. Definitely veridicality is something we looked at as well. But we found that many of the annotation schemes don't also cover this like counterfactuality and propositional attitude and stuff. So as far as we know, this is like one of the widest definitions of uncertainty.
Yeah.
There's also like more specific tasks like hedge detection, which is more like people trying not to be too strong in their messaging about some result. But yeah, it's hard to find a consensus about what should be studied here, but we think it should be as broad as possible, basically. Thanks for your questions.
Thanks a lot, Sander, Brandon. So should continue with the following one. So Arya McCarthy is here, and I guess there was a miscommunication. So they upload their video. It is on the workshop page on the underlined platform, and I could catch Arya for maybe some Q&A, or he may want to summarize it by a couple of emails. So Arya, are you there?
I'm here. I'm actually not registered for this workshop.
No problem.
The lead author of the paper, Jamie Scharf, he's also here, and he is registered. He might be the right person to direct any questions to. I'm sure he can also pull up the slides to give a quick walkthrough in just a minute. But yes, it seems like there was a bit of a miscommunication here. So the best resource for finding out about what we did, which was looking at this longitudinal study of protests in Hong Kong from 1998, basically around the time of the transfer of sovereignty to 2020, would be looking at the pre-recorded video.
So maybe Jamie is here, or
yes. Hi. So I'd be happy to answer any questions that you have, or if you prefer, I can do a quick walkthrough.
A quick walkthrough would be perfect. We have already reserved some time for you, so therefore a quick walkthrough or detailed one, as you wish, would really be quite helpful.
Sure. Are you able to see my screen?
Yeah, we see it.
Great.
Thank you, Jamie.
No problem. Sorry about the miscommunication. But right, so welcome to my presentation characterizing news portrayal of civil unrest in Hong Kong between 1998 and 2020. So as some background, Hong Kong has gone through a long period of protests ever since the 1997 handover. And newspaper coverage about these protests appears to be different just by a simple qualitative observation. And so there's this apparent bias, but there's a question of, great, well, we think there's bias, but how do we actually measure it? How do we actually come up with a succinct way to state there's bias and in these particular dimensions? And so we decided to tackle this problem with an ensemble of NLP techniques. So we have about 4,000 articles from 6 newspapers that are not based in Hong Kong and 2 that are based in Hong Kong. And each NLP method is supposed to tackle a different dimension of bias. Lexical frequency is just supposed to be a simple way to say a very straightforward way to just observe this bias. Topic modeling is just more of a way to say more broadly what topics are different in each newspaper source. Then we also implemented what Goyal et al. Described in her 2020 paper, which measures word semantic shift. And so we attempted to see what is the semantic difference of a particular word in so-called Western-based news sources, as opposed to words that are in Hong Kong-based news sources. Finally, we did some simple sentiment analysis. So we had 19 expert curated keywords, and we applied a one-way ANOVA to split, and we split our corpus by Western-based news sources and Hong Kong-based news sources. And we wanted to see, is there a statistically significant difference in the prevalence of these expert curated keywords in Western newspapers as opposed to Hong Kong-based newspapers. And so we can actually see that there is a very noticeable difference in 15 out of 19 words. And so we can see in this plot on the right that the word democracy appears way more often in Western-based news sources. And so other words that are related to democracy also appear more often. And so the F scores are, the F statistic is quite high for those words. And so we can really see that there's a much greater focus on democracy in Western news sources as opposed to non-Western news sources. And so we can also observe a difference in topics. I'll let you look at these plots in the recorded version. I think they speak for themselves. Oh, I apologize about the formatting on this. But in general, we can see that bias did emerge over time. Some news sources focus on certain events, whereas others do not. And then several of the methods that we listed do demonstrate quantifiable differences in the treatment of protest events. And so we would really recommend that you see our paper for a really in-depth analysis. And again, I apologize for this miscommunication, but please feel free to ask me any questions. I also have actually more up-to-date plots based off of some updated data, so I could show those as well if you would like. Just let me know what would be best.
Yeah, please.
Sure.
You have 20 minutes. You can use it. Please use it.
Okay. Sure. Then one moment to pull this up.
Every study is quite unique and sheds light on different aspects of all these event-related stuff. So therefore, every bit of information really highly appreciated. Thank you very much.
No problem. So in this updated version, we managed to find some additional articles that covered years. Our conclusions are roughly the same, but it just covers more data. And so we can see that, why don't I put this in presentation mode, I'm sorry.
It is in the slideshow.
Thank you. Great, thank you so much. Right. So we can actually see that with the updated data, actually now 18 out of the 19 expert curated keywords are statistically significant. And I've actually listed out the F statistics where protests, democracy, and freedom all have a much higher F statistic. And so we can actually see, again, that Western-based news sources just focus far more often on keywords that relate to democracy. And now when we actually apply the Goyal et al. Implementation of the word shift analysis, we can see that the most divergent words all actually relate to violence. And a lower percentile here means more divergent. So we can see that tension, resistance, severe, confront, occupation, and crackdown all actually score quite low. And so what that means is that the word tension is used in Western-based news sources very differently from how it's used in Hong Kong-based news sources. And so the actual underlying technology is relatively simple. It's just you have a word embedding, you train word embeddings on Western-based news sources, and then you train word embeddings on Hong Kong-based news sources, and then you get you select one word, you get its nearest neighbors, and you get the nearest neighbors in the Hong Kong-based corpus, and then the Western-based sources corpus, and then you see what the overlap is. You know, more overlap means that there's less difference, and so what this means here is that there's very little overlap in how a word like tension is used. But at the same time, words like riot, protest, freedom, democracy, rights, freedom of speech, words that all relate to democracy, those are all actually talked about quite similarly in both Western-based sources and Eastern-based sources. And so what's interesting here is that you can see that, well, specific adjectives or descriptions might be very different by source, yet some big picture ideas, at least in the case of Hong Kong here, really don't change a ton. We also found that after the initial prevalence of the extradition bill topic in news media, there's a divergence. Western media focuses on one thing, and Hong Kong-based media focus on another thing. So Western-based media focus on protesters and social aspects, whereas Hong Kong-based media focus on finance and air travel. But well, thank you. That's what I have to share today. Please don't hesitate to ask any questions at all.
Yeah, thanks a lot, Jamie. Any question or comment from the audience? We have some time. I would just comment, like when we started this our work for protest extraction, we had the target countries, couple of countries. We were afraid of using a language other than English, so we said, okay, we will work on English. And when we observed the data, it was quite different over time, and use of the words, use of different words. So we then formulated the cross-context or shared task, the one we tackled with Tommaso in the first paper. So, and with this presentation, I just say how we are just on the tip of the iceberg. It is, there are many details that you analyze and present quite well. So just showing us there is much more to it. We are just at the beginning, and thank you very much for all these insights.
Thank you so much.
Yeah. So we have questions from, I don't know who was first, but let's start from Tian Cheng.
Thank you for the presentation. So I'm just wondering, in terms of like what is probably the cause of such a difference in terms of how newspaper coverage reports things. Do you think there's probably a fundamental difference in the way people in Hong Kong use the English language, more so than just the bias in the reporting itself? For example, the word tension, how it's used.
So with the asterisk being my PI would be upset if I made any claims about causation. So that is actually a really good question, but I don't think there are actually many significant differences between how English is used in Hong Kong as opposed to how English is being, or sorry, in the newspaper context, how English is being used in Hong Kong as opposed to how English is being used in other sources. But that's just based off of a qualitative interpretation of what's going on, and that's just my sense.
Yeah. Kristine, maybe? Oh, I don't see.
This is a very these are very interesting conclusions. I was wondering, have you thought to publish in a to publish the results outside of the NLP community, like in a political science journal or in a social science in sociology journal, this sociology forum, these results?
So there is currently work underway to do that. Yes.
That's nice. Thank you. Thank you.
So thanks a lot, Jami, Arya, and Risto, everybody. So we really made up this one last minute. So I am quite happy to be able to catch all these people. Thanks for being reactive. So we will continue with Benjamin Radford with regressing location on text for probabilistic geocoding. So we already have the slides. So
okay,
yeah,
great. Can everybody see me and hear me okay?
Yeah.
All right, excellent. Well, thanks so much for sticking around all day for this. It's really exciting to be here, and it's really exciting to see so many people who are interested in extracting political events from text. So today I'm going to talk about a kind of a pet project of mine for geocoding texts, in particular geocoding texts that might be relevant for event data. Okay, let's see here. All right, excellent. So by way of introduction and to motivate why I'm interested in geocoding, this is me. I'm a professor at UNC Charlotte, and I'm a political scientist. So why is a political scientist hanging out at ACL? The reason is that what I'm really interested in doing is taking unstructured text or unstructured data like text and using that to forecast geopolitical events. So think things like wars and military conflicts. But of course, as you might imagine, this little arrow in the middle of this diagram is doing a lot of work. It's hiding a lot of steps that in and of themselves are not necessarily trivial. So I probably don't have to convince people here that one of those steps could be generating event data. So when I think of event data, I think of event data as answering the question, who did what to whom, when, and where. So usually I think this audience thinks of event data primarily as that actor A, actor B, and some action that they've taken. But I also think that for my purposes and for predicting kind of geopolitical events, it's also helpful to be able to extract the date and time that an event occurred and where that event occurred. And so that's what I'm going to focus on today. How do we determine from a newspaper article where these events are taking place? Okay, so I call this geocoding. That's a little bit of a misnomer. Usually when we think of geocoding, we think of taking an address, like an actual physical address written out in text form and turning that into a latitude and longitude, like a pair of coordinates. But in this case, I'm going to be talking about more arbitrary text. So just any text that describes a location. I want to be able to input that into a geocoder and return coordinates. So When I think about what a good geocoder should do, it should have a few properties. One of those is it would be great if the geocoder itself could provide some measure of its certainty or uncertainty in a location. It would also be helpful if the geocoder could learn from like contextual clues in the text. We as humans are great at doing this, but gazetteer-based or dictionary-based geocoders are not. So I'll give an example of that in just a minute. And also, it would be nice if a geocoder could identify location in text, even if there's like noise, if there are irrelevant locations in that text, or just irrelevant words. So here's an example that I'll use to motivate kind of this project. I just made this up yesterday. And I obviously don't know anything about basketball, but imagine you have these two sentences, right? Basketball fans gathered in Washington to watch the Wizards NBA team play. We as humans, if we knew anything about basketball, we would know that this probably refers to Washington, DC, because the Washington Wizards are Washington, DC's team. The other sentence is exactly the same, except for the team. Basketball fans gathered in Washington to watch the Supersonics NBA team play. And so this should refer to Washington State circa like the early 2000s when the Supersonics were playing in Washington State. But there's no location names that would like give that away. All right, so the model that I've developed, I call it ElectroMap from the Transformers cartoon. It stands for end-to-end location estimation with confidence via transformer regression. Basically, it's a probabilistic neural network built on a transformer language model. The idea is that you input text, in this case, like a paragraph from an article. There's a transformer language model that's based on Distill Roberta because I had limited GPU cycles. And so I picked something that was pretty easy to train. The output, because it's a probabilistic neural network, are the parameters of a probability distribution. In this case, it's the means or the directions, the concentrations, and the mixing proportions of a mixture of von Mises-Fisher distributions. So the von Mises-Fisher distribution, it's basically like a Gaussian distribution on the surface of a sphere. So these are examples of von Mises-Fisher distributions. And you can think of a mixture of von Mises-Fisher distributions as just being a combination of multiple of these kind of hotspots on the sphere. And of course, the sphere in our case is going to be the globe. Okay, this is the only mathy slide that I have. The loss function that we're minimizing, because it's a probabilistic neural network, is just the negative log likelihood of this probability density function. So in this case, that's, again, the mixture of von Mises-Fisher distributions. Okay, so how does it work? What I did was I scraped Wikipedia for a training and testing set. So I collected all of the geolocated articles on Wikipedia. I have them for all languages, but I'm only going to do English here because I had limited time to train this. So we're only going to do English, but in the future, I'm going to try to do other languages. So here I have 1.2 million geolocated articles that make up the training data set, and then just about 13,000 for validation and test data each. There's kind of a discrepancy between the size of the training data and the size of the test data because the model I compared to was a little bit slow. And so I picked kind of a smaller test data set so that I didn't have to wait forever for that other geocoder to chug through 100,000 results. So here is an example from the test set. This is from the Wikipedia entry for Hanover Lutheran Church. I won't read the whole text, but basically it's a Lutheran congregation in Cape Girardeau, Missouri, yada, yada, yada. So this one should be relatively simple. You would hope that the geocoder would find something close to that town in Missouri. So here are the results. On the left, we have the state of Missouri, and then on the right, we have this red insert. And then the diamond in the very center of that insert, that's the predicted location. And then the actual location is in the red star below that. So we're about on average, we're about 37 kilometers off. Those contours that you see, the circles, the concentric circles in the prediction, those are a 95% confidence interval around, or 95% prediction interval around our prediction. So clearly the target is well within that confidence range. Another example that might be a little bit harder, Pil is a village in Iran. I can't pronounce most of those words. and its population is 53 people and 23 families. And this is the entire text. So here are the results. On the left, we've got Iran. The inset is highlighted here. And the model got within about 13 kilometers of the result. And once again, those concentric rings represent a 95% prediction interval around the estimate. All right, so back to our hard NBA example from the beginning. Can this model learn from text clues or context? So on the left, we have our Washington Wizards. On the right, we have our Washington Supersonics. And you can see that the model can distinguish between these two things. I just plugged in the latitude and the modal latitude and longitude from the prediction from the model into Google Maps, and that's what we have here. You can see that it doesn't actually nail Washington, DC, and it doesn't really nail Seattle, which is where the Supersonics would have played, but it does at least get the general vicinity right. So it's close. All right, in terms of overall evaluation, I won't talk about all of this, but generally speaking, the model performs well-ish on the test set. So the median error is about 44 kilometers, but there's a long tail to that. It's pretty right skewed. And so the mean error is about 108 kilometers. Excellent. All right. And so in conclusion, next steps. Like I said, I'm interested in applying this to using a multilingual transformer to see if we can do the same thing only for texts in all languages or a lot of languages. So that'll be next. Also, I think that we could do better evaluation of ambiguous cases because we could generate ambiguous cases ourselves, like synthetically, and figure out kind of what are the limits of the model and in terms of being able to infer context clues. And then finally, I'd like to apply this to political event data rather than Wikipedia data. And with that, I'll conclude. So thanks very much. I'm happy to answer questions if we have time. And if not, this is my email, and I'd be happy to answer questions over email.
Thanks a lot, Ben. It is another place where transformers help us to remove a lot of manual work or hard work, let's say. And I really wished that your feature work works because we need it. So I was just thinking about all this practicality it could add. So we can accept one or two questions. I'm not sure who raised hand first, but we can start with Alexandra.
Hi, thank you. Yeah, so I am also interested in unstructured text, but I work with social media data. I was wondering if you've looked into the geolocation tools for social media data. I know there's some out there for Twitter, like Carmen or Pidgeo, and there's also some out there for Reddit. Did you think those could be, some of those methods could be applied to more formal text, like news articles?
Oh, that is a great question. And I don't know the answer to that. So I'm not familiar with the tools that you mentioned. So if you wouldn't mind maybe putting them in the chat or just, sending them to me somehow, I'd love to take a look at them. What I've seen for geolocation on social media, and in particular Twitter, I've seen some work on trying to infer locations from like the entire post history of a user, and which I believe works similarly to how this would work, in the sense that you're looking for like location clues in the text that they've used, right? So if they complain about a traffic jam on a highway or something, you can maybe infer where they are when they do that. But as far as actually using social media with geolocations, when I've done that in the past, I've just like subset to the 2% of people who leave their geolocation in their profile. But I'm not familiar with the Reddit work, so I would love to take a look at that if you don't mind sending it my way.
Yeah, of course, I'll post it in the chat. Thanks.
Thanks so much.
Thanks a lot, Alexandra. I have in my list Brandon next.
Sure, yeah, I can try to keep this quick. Really cool work. Thanks a lot. I was wondering how well the dispersion for the von Mises distributions is working. Like, is it the case that when there are geographical units that are larger or more vague, something like Midwest, not even well-defined semantically, right? Is it the case that you actually get a more spread out distribution? And also wondering about how to this, is it a 5-mode distribution? Are you getting that at all?
Yes, so those are great questions. The answer to the first question is that I've actually been very surprised with how in the limited evaluation I've done so far, I'm surprised with how well the concentration parameters actually work. There are a few examples, and I tried to pick, pseudo randomly picked examples. I just went through the first 100 test cases and picked some that were some that were really tight, like the Iran example that's particularly tight is off by 13 kilometers. And then I picked some that were much less tight. So I have one where the error is 100 something kilometers, and it's because the target is in the middle of this forest, and the concentration parameter represents that, which I was pretty impressed with. To the second question about the 5-modal distribution, the answer is no. Usually you don't get that. So usually one of the mixing weights is almost 100%. It's 99%, and the rest are really, really low, which makes you think oh, well, why don't we just use a single von Mises-Fisher distribution instead of a mixture of von Mises-Fisher distributions, which would be a really great thing to try. And I did, and I can't get it to work. It always collapses to predicting 0, 0 or something like that. And with a really, really large small concentration parameter, so really high variance. And I don't know why that is. I haven't figured it out, and I'm a little bit hesitant to make guesses because I don't feel confident that I know. It could be that it's a mistake in my code for sure, but it could also be that there's some kind of weird mode collapse or regression to just a mean point that's happening for some reason. I just don't know why that would be. But that's a good question, and I don't actually know why it's the case that this works better than a single von Mises-Fisher distribution.
Yeah, I don't know if this makes you feel better, but there's so much Bertology work that finds just some of the heads just do crazy things or specialize in different ways. Maybe those 5 different, one is good for cities, one is good, I don't know, whatever.
It could be, because it's not always the same component that is the main component. So I thought maybe they're specializing regionally or something. My hope at the beginning was that if you had a thing like Washington, DC, one of them would be centered on Washington, DC, and another would be centered on Washington State, and they'd have different weights, but that doesn't seem to happen at all. They tend to be spread out geographically, seemingly randomly, except for the main one, the highest mode distribution.
Thanks.
If I find out, I'll let you know, but I haven't figured it out yet.
Thanks, Brandon. We have Osman.
Hi. So thank you for the talk, and forgive me if I'm a bit skeptical, because this is the first time I've seen something like this, and this thing showed sounds incredible, because you can even predict a place in Iran, for example. I'm trying to understand what you're doing here. You're directly predicting the geolocations, not categories or something, just directly predicting longitude and latitude values.
That is correct. With the caveat that it's not, the output of the neural network itself isn't latitude and longitude. It gets converted to latitude and longitude.
Yes.
The output is an XYZ Euclidean coordinate on a unit.
Okay.
And then that gets projected onto the unit.
But it's still not categories, and you train this with something like 1 million entries from Wikipedia.
That's
your
correct.
model has to have some a giant memory, then something like that, in my opinion, because.
So I totally agree with you. I think this is a situation where the model is memorizing landmarks, for example, countries and provinces names, and then what it's doing is somehow interpolating between those. So if you say this town located in the southern province, right? It just says, where is the southern province? I haven't seen this town before, but I'll put it somewhere in here, is my guess.
So there are several indicators in your texts, and some of them are higher level, like you said, some southern province or like in the southern regions of some country, maybe. Like there are higher level indicators in text, and there are some medium level and some lower level. And if you miss the lower level, you can still recover from the higher levels, you say. This is your theory.
That's my theory, because I can't think of any other way that it would work. So this is the Iran example, right? Which actually has a lot of location information. And so my hunch is that it is just interpolating between the ones of these that it has seen before.
I see. Because I would love it to be deployable. You know, I would love it to be deployable.
I would too. I will let you know if I think it is.
Thank you.
So one more thing, you mentioned having a big memory bank.
Thank you for the great talk. And
yeah, so I was going to say this, I'm using a pre-trained distill Roberta model. So it is already pre-trained on like a huge corpus of text. And so there's probably some good relative location information in there.
So guys, thanks for the lovely discussion, but we need to move on. Thanks a lot, Ben. You have been contributing to this line of research for a long time. I really appreciate it. So for the next talk, we have Alok Kumar. Let me double check not to have any.
Yes.
Yeah, welcome.
Yes. Am I audible? Thank you.
Yeah, and he will tell us about extracting events from industrial incident reports. So the floor is yours.
Okay, thanks. I will share my screen.
Yeah.
I am Alok Kumar from Teachers Research India. I would like to present our work on extracting events from industrial incident reports. As we all know that industrial incidents have a large socio-political impact, and we need to minimize their occurrence. Investigation of incidents is carried out to identify root cause and prevent reoccurrence. In most cases, reports summarizing incidents are available in incident document repository, and investigations are mainly carried out manually. There is little work in automated processing of incident reports. Important NLP tasks in automated processing of reports involve identification of domain-specific entities, identification of domain-specific events, identification of entity and event relations. In this work, we focus on extracting domain-specific events from incident reports. We now discuss on events and their definition in this domain. Events are specific occurrences that appear in the text to denote happenings or changes in states of the involved participants. For example, construction, here working, removing, killed, injured, etc. Another example from aviation incident is also shown. We have made three main contributions in this paper. First one is annotating a moderately sized incident text data set for evaluation and weak supervision. Second one is employing a transfer learning approach based on a standard Bijl sequence labeling architecture. Third one is analysis regarding effect of increase in pre-training data and explainability of why pre-training improves the performance. We now move on to our first contribution. We followed open domain event extraction guidelines proposed by Araki to annotate our data set. Consider this sentence. The helicopter crashed in the field and sustained substantial damage. In this sentence, crashed, sustained damage are marked as events. We differ with Iraqi guidelines at certain places, such as we do not label individual adjectives and adverbs as events. Also, we only as events and do not extract events describing long-way streets. One may refer to our paper to read about details of the guidelines and differences with Iraqi. Event extraction from incident reports can be posed as a supervised sequence labeling problem. A bi-LSTM CRF-based sequence labeler can be employed to train a network. However, the challenge is non-availability of a large event-annotated incident dataset. The solution we propose is transfer learning-based sequence labeling. We hypothesize that pre-training a bi-LSTM CRF sequence labeler with event-level data from the general domain would help the network know about the general nature of word-based event and nominal events. Later, as a part of transfer learning procedure, post-training the network on a small incident event-level data set, this would provide us with an enriched incident event labeler. The transfer learned model is then used to predict event triggers while testing. The figure shows the block diagram of our proposed approach. We further enhance the bi-LSTM CRF network architecture to work with transformer-based high-dimensional input. The challenge here is generally transformer-based word representations are high-dimensional. Also, it is not possible to train a standard bi-LSTM CRF using high-dimensional input representations with a small training data. We devised a solution by introducing an input transform layer as shown in the figure and mapping the high-dimensional word embeddings to lower dimensional embeddings, say from 768 dimension to 200 dimension using linear activation. As a part of experimentation, following other dataset statistics as shown in table 1, we base our experiment on incident from aviation and construction domain. In the setup for representing text tokens as inputs in the proposed neural architecture, we experiment with glove-based static embeddings and BERT and Roberta-based contextual embeddings. Hyperparameter tuning has been performed using 5-fold cross-validation on training subset. All results are averaged over 5 trained test runs. We compare our work with 3 baselines, B1, B2, B3. B1 is a rule-based approach proposed by Palsekar et al. B2 is an open domain event detection using distinct supervision proposed by Araki and Mitamura. B3 is a standard bi-LSTM neural architecture for NER proposed by Lampel et al. Our proposed approach outperforms all the 3 baselines as shown in the table. Also, there is a significant improvement in recall compared to the baseline B3 in the construction data set. In the transfer learning approach, we pretend the network with varied amount of retraining data, say from 1% to 100%, and check the performance on test data. It can be seen that with increase in retraining data, the performance improves and reaches a peak between 30% to 70% of pre-training data available. Interestingly, BERT-based representation starts showing promise with even 1% of pre-training data. We further contribute by explaining why is pre-training helping. To explain this, we need to have an understanding of what the network is learning about the input embeddings and the context from the BILSTM network. The challenge here is predictions from a neural network are generally not explainable, and the role played by the hidden representations in the predictions is difficult to analyze. We hypothesize that interpreting internal representation in a neural network would require an indirect observation to decipher what is captured by them. One such indirect analysis of these internal representations involves performing their clustering and observing if representation with similar and dissimilar representations. To help with our hypothesis, we consider all the tokens marked as events in the gold dataset. We obtain BILSTM output representation for these tokens by passing their sentence through TL and B3 model, truncated till input of CRF layer, as shown in the figure. We categorize the predictions of TL and B3 model into correctly predicted as events or marked as non-events. We found that the representations RTLC and RB3C belong to clusters which are highly separate from the ones housing the representations in RB3I. We further strengthen the claim by computing purity of the representation clusters. The prediction based on glove embeddings has a purity score of 0.9781, and the prediction based on BERT embeddings has a purity score of 0.9832. This is the summary of our work. We plan this as our future activity. Thank you.
Yeah, hi. So
thanks for the presentation.
Yeah, if you have any questions, I guess.
Yeah, sure. Thanks for this work and your contribution.
Yes.
It is a different low resource event type, and I love to see it. Thank you very much.
Thank you.
So, any comment or question from the community? So I guess people are tired, so I feel it myself,
yeah.
to be honest.
Yeah, almost.
Yeah,
yeah, almost second last period.
Yeah, and in the chat, it can be written, or people have your contact information in the paper.
Yes.
Yeah, thank you very much. All of
Thank you. Thank you.
So we will have the last talk on another aspect of the events and the text data from Shaina Raza. It will be automatic fake news detection in political platforms, a transformer-based approach. Shaina, are you around?
Yeah, I'm here. Thank you. So I'm going to share my screen.
Sure, please.
So I think
you see it?
Yeah, okay, you can see that.
Now it's perfect.
Okay, thanks. So I'm Shaina Raza from Ryerson University, Canada, and the publication that is accepted in case 2021. The title is Automatic Fake News Detection in Political Platforms, a Transformer-Based Approach. So I will be first talking briefly about the motivation behind this research, problem definition, proposed method, data set, evaluation metrics and baselines, results, and conclusion. So the motivation behind this research is a series of events that happened in the last few years. For example, according to First Draft News, the current system, the current disinformation crisis system in America is the result of more than 2 decades of corruption in the news ecosystem. And then in the US election 2016, we see that there was a lot of manipulation of the algorithms, either on the social media platforms or on the news websites or different applications where the algorithms have been manipulated to produce fake news. And also the term fake news was coined for the first time in the literature, especially if we talk about the search engine or this kind of literature, it was coined for the first time during that time period. And then in the elections 2020, we see that there was much awareness among the public and the journalism and the media that they know about the manipulation of the fake news. However, still we see the consequences. This is because the tactics of the fake news change over time. The fake news spreaders, they change their techniques, the way they produce fake news, they manipulate the data, that also change over time. And the consequences are clear that we see on the storming of the US Congress Capitol. And then there are also a couple of events, for example, Elon Musk Bitcoin scandal, the fake news that resulted in millions of dollars loss. And then the fake news about the Obama death in 2013, and that resulted millions of dollars loss in the stock exchange. So these are a series of the events that motivated me to have a research in this line. The problem definition in this paper is that given news and associated side information, the task is to determine if a news is fake or real. So when I talk about the news in this paper, so I mean news, basic news information, for example, news ID and news title. And when I talk about the side information, so I mean news related information, for example, that could be news body, news taxonomy, news source. And the social context basically refer to the interactions of the user on the social media. And those interactions could be in any form, for example, tweets, retweets, upvotes, downvotes, commenting, sharing, propagation, so many parts. And then the temporal information is very important related to the news and also the fake news. The reason is that if we get to know, then when the fake news is published, the time of publication, and when it has been, then it is going to spread, and getting that kind of information, we are able to have an early detection method, and that can help a lot in mitigating those fake news and preventing it from spreading far. So in this work, I treat the task of the fake news detection in two ways, binary classification and the multi-classification problem. For the binary classification, I consider the labels fake and the real, and for the multi-class classification problem, I consider the cases fake, real, and the mixed. So this is the proposed model that I name it Faker, and it is based on the well-known transformer-based models, transformer-based model, like the previous presenters already have presented it very well. That I can briefly tell that transformer-based are basically the NLP models, and they are widely used in the state of the art these days. And I mean, the success of these models can be seen with the success of Google BERT that has shown a remarkable performance in the history of the search engine. So this is also the model that I have used in this work. And during this research, I find two limitations of the transformer model. First is that the transformer model take everything as one piece of document. For example, if I talk about the news articles or the social media context, or maybe any kind of information related to the news or the social context, so we can see that there are different type of information. For example, news headline that could be manipulated as the clickbaits, news body, news source is a very main thing, because there are many sources that are fake, that are producing fake news. There are many sources that are reliable, and some have no identity and so on. So it is very important to capture different pieces of information, and especially in the case of the news and the fake news. So the limitation of the transformer model, as I explained earlier, is that it takes everything as one piece of information, which is not good, because different piece of information related to the fake news, even other IR scenarios, should be evaluated and ranked or weighted accordingly. The second limitation that I have noticed in the transformer-based model, although lately I will give a counter argument of my own point. During the time of writing this paper, I find that the traditional transformer-based model, they take everything as a lexical information, text-based. I then again say that I have myself a counter argument for this one, because lately I see that there are many transformer-based models that are based on the visual and the streaming-based information. So this is during the time of writing this paper. So I have addressed these two limitations in this work for the fake news detection problem. I briefly explained this model. So at the like very bottom, you see that there's a news articles with the site information, and here by the site information, I mean the different information related to the news social context. And for each information, like we have also the social context and the temporal information. And in this work, I have considered not only the lexical information, but also the non-lexical information. And by that, I mean the temporal information or other information that could be in the floating point or the numeric representation. For example, let's say upwards, downwards, the ratio of them, these kind of things, which are not lexical. So I have considered both of these. So the very first layer you see is the embedding layer, and the input to the embedding layer is the sequence of the word from the news. And the CLS token is added at the start of the sequence that will later be used for the class level prediction. And I have utilized the basic BERT embeddings in this work, the token level embeddings, text segment embeddings, and the position encodings to have representation of the temporal representation of the sequence as well. So the basic architecture is very default to the BERT architecture that we can find from the Jacob Devlin paper or the Vaswani paper. Although I also say that the same architecture that I propose in this work can also be used for the other transformer-based model, for example, BART, T5, and other models. So the input from the embedding layer then goes to the next 12 layers of the encoder. And after the encoder, it basically goes to this fusion block. So the idea of this fusion block, I have cited in the paper also. I have taken from another paper, and that paper is words can, the title is like words can move, something like this. So basically that paper has used the idea of the fusion block. However, their work is a little bit different. They have tried to integrate different multimodal information, for example, the visual, the other streaming based information, audio based information. They try to like integrate them and then try to produce a representation out of that. Different from their work, what I did here, I basically use the same attention, the fusion block and the attention getting mechanism to fuse a different site information, and also that site information is heterogeneous in nature. By heterogeneous format, I mean some of them are lexical, some of them are non-lexical. So I have integrated those different site information that is also heterogeneous in nature using this attention getting mechanism. That is basically used to produce two context vectors. The first one is the lexical vector, and other one is the non-lexical vector. And the non-lexical vector is later normalized using normalizing, that is basically a normalizing like weighted normalizing factor that I mentioned in the paper in detail. And then both of these vectors, lexical and non-lexical, are integrated to produce the final news representation. That is a combination of different site information that is then passed to the second encoder block. And then finally, the classification, the model is fine-tuned to have the classification mode in which we will get the labels in the form of the binary classification or even the multi-label classification. So for the dataset, I have used the NILA GT 2020, and that dataset was released last year. It consists of the news articles and the tweets data from the year, I mean, for the whole year 2020, January 1st till 31st December. And it has two basically important parts, the COVID-19 part and the 2020 US election part. So I have used the later one for this one. For this particular problem, the data is timestamp and event based, and it is purely based on the, the part of the data that I have used is purely based on the 2020 US presidential election. So the dataset itself has provided the source level ground truth labels that are collected from the media bias and fact check websites. The dataset has not provided the ground truth labels at the articles levels. So as suggested in this, in the main paper itself, that we can use some other techniques, for example, weak supervision to have the data labels for each article. So what I did in this case, I used the distant supervision, weak supervision to assign label to each news article based on the source level ground truth label. So I acknowledge that the like if we use the weak supervision, the ground truth label that we get at the news article level may be imprecise or maybe partial, but the research show that the same weak supervision can be used to produce stronger models. If our model is basically having a strong predictive ability, then we can rely on this. And we have also demonstrated in the results that although our ground truth label is based on the distant supervision or weak supervision, but because our faker model is a strong predictive model, and so we are able to get better results than the state of the art. For the evaluation metrics, I've used precision, recall, accuracy, F-score, AUC, the typical accuracy-based metrics that everyone is using. And for the baselines, I have a mixture of three types of baselines. First is those models which are considered as benchmark in the research of fake news detection system. So I have considered those one as baselines, and the second one is the line of the transformer-based models. I have used different transformer-based models, for example, BERT, GP2, VGC and BERT, that is a combination of the graph convolution neural network with BERT. And I have also used some of the other baselines, SVM, deep fog. The idea of having a mix of the baseline is to evaluate our model compared to different kind of baseline and see that where we are standing. And we have performed the temporal offline split, and the data is split in such a way that the indexes of the text data is greater than that of the training data and also the validation data. In terms of the results, so I can show that our model faker. So here I can demonstrate that we are able to have a better accuracy in terms of accuracy F1 or AUC ROC measure for both the task, the binary classification and the multi-class classification compared to all the baselines. So the results are showing that like the way we have the predictive modeling and the way we have all those kind of labeling that fit the task at hand. And this is a brief example on a sample of the test set just to show that, and this is the case of the binary classification. So I just want to show that how our model worked on a subset of data. So basically, like here we have this is a confusion matrix. Everyone is quite familiar with it. So the total sample set that I have used for just to present this example is 4,000. And out of that, I am able to achieve 2008 true positives and 1845 true negatives. My purpose of showing this example is to show that the precision of our model on this sample set and also demonstrated in the other results is quite good. It showed that we have very fewer false positives. And the recall of this model is also quite well. It is 98.81%, and that shows that it has fewer false negatives. Here I want to mention that having false negatives in the fake news detection problem is a very severe and kind of offensive thing in this regard, that a news that has already been labeled as like a fake, it has been entered in the system by the model. So having a more false negative is a bad thing. By showing this example, I can demonstrate that in this faker model, very few false negatives are being entered as a part of the system. And this is like a very good case compared to the baselines that I have shown in the paper also. And I also performed the ablation study, and in which basically I have taken the all model with the every information, all type of information that I have mentioned earlier, social context, side information related to the news, temporal information, And then in the ablation study, step by step, I began to remove some of the part of the information, some of the module. For example, in the faker end, I just considered the news related information. I eliminated the social context. And then in the faker S, I just considered the social context. I removed the news related information. And in the last three parts, basically, I consider the default faker model within news information and the social and temporal information. Only thing that I remove is the headline. In this part, I remove the news body, and here I remove the source. So the purpose of showing the ablation study is to check the effectiveness of different kind of information in this work. And here I can like say that if you consider all this information, news related information, social context, temporal, all together, the model will perform best as shown by the better AUC. When we only consider the news related information while removing the social context, the performance is impacted, but the performance is more impacted when we remove the news related information and just consider the social context. So on the basis of this, I can state that like the news content itself is carrying more information about the fake news compared to just the social context. Because even the social context, the social media interactions, the social interactions of the user on the fake news depend on some news. So it clearly showed that having a news body, news taxonomy, news source, news headline, etc., carry more information about the detection of the fake news compared to just the social context. And in the last three results, I can show that when we remove the news body, the performance is very much impacted. So this clearly shows that news body is carrying too much information that is also contained in the source, taxonomy, and the headline of the news. So removing this from the training set impacted the performance. And between the headline and the source, we can see that when we remove the source level information, the information is impacted. And just 5 minutes left. Okay, so information is impacted, but a source is more important. This is very much clear. The reason is that the source of the news, for example, the CNN, BBC, the Onion, etc., they are carrying a lot of information about the veracity of the news and from where the news are coming. So in conclusion, I propose a transformer-based model considering news content and social context. And in the future, I would like have to more social context such as friends network, propagation path, etc. I would like to mitigate the concept drifts, and I would like to utilize other data labeling rather than simply the weak supervision. And I would also like to consider the biases of the source level labels. And I would like to mitigate the filter bubbles. And finally, I would like to have, currently the information is based on English corpus. I would like to incorporate more multilingual information and more multimodal information. Thank you.
Thanks a lot, Shaina. This was a great different aspect and a lot of work with the state-of-art results. I particularly loved the ablation study. It really sheds light on what's going on.
Yeah.
So anybody has any comment or question? So maybe we can continue tomorrow. Tomorrow we will have 4 invited talks and shared tasks, shared task results. So all shared tasks will have a slot to present, some longer, some shorter, based on their best score or not. And for anything, please contact us. Our contact information is around on the page of the workshop as well. So have a nice morning, afternoon, or evening. Bye-bye.